your voice over IP calls, WebEx, Zoom, and so on. And then there are multi-group interactions, larger conferencing tools, and so on. And then there are applications where you need massive caching. And this is where DHHLS comes to play, and then global scale. I mean, World Cup is going to start in a couple of days, and millions of people, hundreds of millions of people will start streaming that stuff, right? That's how how much scalability we need for big events. Now, the first application I'm going to show in one slide is the first demo we developed last year, time travel in mock conferencing. This is based on our own implementation, Mocktail. And we have a relay over here, as you can see, if you can see my mouse. And then there are participants. Obviously, you can have as many participants as you like. They have a single quick connection open to the relay, and then they are just doing video conferencing. There is really nothing fancy about this. There's a screen sharing, there's audio, there's video, and then everything, right? But one nice feature of this relay is that anything goes through this relay is actually cached for some time. So you are in the middle of a meeting right now, let's say Zoom meeting, and then you were playing something else or watching YouTube or Netflix on the other screen, and then you missed a question that your manager was asking you. I mean, there is no way to actually rewind a Zoom meeting or a WebEx meeting or Google Meet meeting and then come back to the question, right? Actually, with this time travel feature, we do that. We have a rewind button on the interface, and then you can rewind like 5 seconds, 10 seconds, or 10 minutes. Or you are late into the meeting, you can start from the beginning. While the meeting is going on, we are running this on-demand part of the or DVR-like video conferencing video. Now, this gives us a single platform that we can do everything all together. Timetravel.mocktail.dev if you would like to try it yourself. Now, the second demo I'm going to talk about is Watch Party. Watch Party is really for younger generation. I don't really find it very interesting or exciting, but apparently it's a big thing for young people. So the imperative behind social viewing is you might be in different places, even in different continents, if you like, doesn't matter. But they would like, people would like to watch things at the same time. I mean, this is really to, share some emotional context and so on. And this certainly improves the customer or user engagement, and as well as improves on your retention rates. So it's a useful thing. Apple has this, Netflix has this. There are so many free applications out there that you can do this. Now, when we look at all those applications, actually, we see either some proprietary protocols or we see some combination of different protocols. Now, the scalability is important here. Maybe you are going to be 10 people in your watch party, but there will be thousands of parties running in, at the same time. Fidelity is important. The quality matters, right? And there's a paper from TNO guys in Netherlands. They show that if sync latency is less than 200 milliseconds, usually people are just happy. It is virtually transparent to the viewers. Anything less than 500 milliseconds, it's acceptable. But beyond that, it becomes unacceptable, and there's a spoiler zone. So if you see something about the video, like a goal or a score or something like that, and then you start cheering about it, then your friend hasn't seen it, it's going to be a problem. So, for example, when we tested this, our relay was in Frankfurt, not too far from here, and then there were clients from in Istanbul, and then there were clients all the way in Vancouver in Canada. So the round trip is at least 200 milliseconds, but we were able to keep the sync latency less than 500 milliseconds. Now, most of those platforms that you use today, they have two different stacks. For the real-time excitement part, the communication part, they use WebRTC. And for the streaming part, if it is a football game or basketball game or World Cup, whatever, they use DHHLS. And there are two different stacks they are trying to maintain together. So that's what I call as a Frankenstein. And, this is the problem that Mock actually solves very nicely. So there is context pipe as we define. That's your main program, football game or a movie or live sports and so on. And then there's excitement pipe where you are interacting with your friends, like they see your video feed, and then you see their video feed, and then there is audio communication as well. Now, context pipe needs to be not necessarily low latency, but it needs to be perfectly synchronized across all the viewers. Doesn't matter if you are in Sydney versus Vancouver versus Istanbul. But the excitement pipe needs to be really low latency. It's like real-time communications. So we are trying to shoot or achieve two things at the same time. Now, we have only from the Lord of the Rings. So we have a single relay that will communicate all these different streams for us, excitement pipe as well as the context pipe. So first of all, it's a single relay. It's easier to manage, easier to develop, easier to debug. And then since everything is under a single shared quick connection, that means that you can prioritize things accordingly. So I know my context video is the highest, highest important content. So I can actually give high priority to that stream as opposed to my friend's video or audio, right? And mock relays are payload agnostic. This is very important. They don't even touch or look at the payload. They just look at some mock header stuff, extensions, and priority levels to schedule things, how they are going to work out. So this is the architecture that we developed. You can also test this at watchparty.mocktail.dev. So there's main content coming in. It's a live sport or big buck body video. It goes through a real-time encoder, and then it gets published. And then through the relay, it gets delivered to our folks in the party room. And then there is a party server where we are managing the room-specific features and so on. And each partier is also sending their video and audio to other parties. So the main content is coming in from the publisher, and then each of these is also publisher subscriber. They are sending their video feeds. There are a lot of tracks, as you can see. There's control stream, catalog track, timeline track, audio track, video track. There is partier audio, video, text, and so on. So they are all within a single quick connection that we manage carefully. Now, something we termed as a dual pipe strategy, because we have two different applications with different requirements under a single quick connection. So I have my control stream, which is by definition the highest priority, most important stream in quick, mock transport, sorry. And my context pipe. This is where the World Cup video, football video or Big Buck Bunny video is coming, and there's audio, video, and so on. And then there are different audio video feeds coming from each partier. So if we are 10 people, 9 other people are going to be sending their data to me. Audio is actually mapped to quick datagrams. We don't really do retransmissions for that, but the video is still using quick streams with retransmission enabled, but there's an early discard policy. So if the video is not gonna make it by the deadline, that POP is going to be canceled, and then we move on with the next POP. So this avoids accumulation of latency when So the most important feature of mock, if you ask me, is the prioritization capability. So when congested, obviously when things are not congested, when everything is running just fine, it doesn't really matter if you use mock or something else. But under congestion, excuse me, it starts making a difference. So I have my context pipe coming in, and then I have my partiers coming in to the relay. Again, highest priority, and then high priority, main content. And then from each partier, there's audio, video. Party audio is medium priority, as we define it. You can change this if you like. This is latency critical, but unreliable. If the audio is going to make it, let it make it. Otherwise, we are just going to drop it, right? And then party video is low priority. I would like to watch the football game before I see my friends, right? I don't want my football video to be interrupted because of a friend of mine, right? This is latency sensitive, but it's also cancelable with early discard capability. If I don't have enough bandwidth to a single partier or to me, right? So I don't really have all the bandwidth to support the main context as well as all these partier videos. Actually, I'm gonna start dropping something. What I'm gonna drop first? Well, the partier video. So maybe your video is not gonna make it to me, but my football video is not gonna be interrupted. Now, if there is much less bandwidth, then I'm just going to get the football video, but I'm not going to get any audio or video from the party. And then this is all adjusted in real time. Now, implementing this was really a big hassle for us. I mean, we learned a lot of things on the way. And as you know, the code quality wasn't really perfect. But over time, we tried to perfect it, and it's working relatively well now. And using this original meme, we developed our own. We tried to do this with WebRTC versus mock, and then you see the what the fuck per minute rates between two different implementations. So this gives us a lot of extensibility and capability when we are doing this kind of things in a single protocol. Today, there are several mocktail relays in different parts of the video. There's one in Frankfurt, there's one in Chicago, there's one in Singapore, and one in Osaka. And these are Akamai Linode nodes. They are both publishers and relays. And there is also the AWS relay for a bunch of our demos that we are running, and it's also in Frankfurt. And we have load balancing between these nodes. If you just go to relay.mocktail.dev, it's going to give you the closest relay node. And this is thanks to sponsorship from Cloudflare. So that's all I wanted to say. Please try to code yourself. Look at the examples, demos, and everything. Just don't abuse the relays. We are paying for them. My students are working on new demos, all the time. We are trying to come up with interesting use cases for where mock is going to make a lot of sense. And we are also part of the Open Mock Foundation. I just want to say a couple of things about it. So it's an industry consortium that brought several companies together, especially the CDN companies, and they are trying to build a public relay that will hopefully power all these CDNs in the next couple of years. There is also a players track. There is also ingest track where other companies are showing interest, but most of the emphasis is on the relay implementation. So you can go to openmock.org and look at what they have done so far. Thank you.
Has anyone got any questions for Alan? Tim Panton.
What's the likelihood of there being a peer-to-peer story added on later?
What do you mean exactly?
So it's very centralized, that architecture, and I'm wondering if there's a peer-to-peer.
The relays can be distributed, right? I mean, you don't need to have a single relay. There could be a network of relays, and then you can have relays anywhere you like. And yes, everything needs to go through a relay, but doesn't have to be the same relay, if that's what you're asking. And by the way, mocktail relays, these are not communicating with each other yet, but that's our own to-do list. Yes.
Yeah, hi. Another question about relays, actually. So obviously, if we want to, get the, CDN scale of reaching, millions of subscribers, we're going to need a big, a big network of relays, essentially. How can I ask this? Is this just a matter of waiting for, bigger companies to just set up more and more relays that we can use, or is there maybe a strategy that I can set up a couple of relays for myself, but then I'm not going to get that reach as well? So it's a matter of, if I want to do a big stream, just waiting for big people to set up a lot of relays.
Well, I believe yesterday you told me that you use Cloudflare's relays now, right? I mean, they have the largest deployment now.
Yeah.
It's not the latest and the greatest version. They are running a bit behind, but they at least have a distributed relay network. Now, Akamai, CDN 77, and a couple of others are also on board, which are behind this Open Mock Foundation. So you could expect, I mean, obviously that depends on the customer interest as well, but you could expect some mock CDNs becoming available in a year or two.
Okay, thank you.
Is there a standard way of a relay, I guess, authenticating a connection? I mean, you said in yours, please don't abuse the relays. Obviously, you know, eventually, like, somebody's got to pay for these relays. So what's the kind of access control mechanism?
Yes, there's a, I mean, there's token-based approach that is being standardized in the working group. We don't have it yet, so I just trust that we are not going to abuse it. So, but eventually there will be token-based authentication.
Anyone else? I'm not certain if it was, I was busy doing other things. Was it answered in the talk? And if it was, just tell me and I'll go rewatch the talk. But how is, you know, the standards and in terms of people being able to go and build things with multiple different tools from all over the place? And how does it, like, how does that work today? Is it good? Is it bad? Is it kind of?
I think it's a good thing. The ethics of running code in the IETF is very useful. There are multiple implementations, including ours. And yesterday and today is the interrupt testing in London again. So people come together, and then I would like to test my relay with Lorenzo's relay and so on, so we can see how it works, right? Because you know we are all reading the same text, but we might be understanding different things from that text, and that's something we are trying to fix as much as we can.
Thank you very much, Ali. Everyone give Ali a round of applause. Mic back up. Hello. While Lorenzo is setting up, how long have I known Lorenzo? A very long time, it feels like. How long have we known each other?
Super long time.
Super long time now. So Lorenzo heads up, he's the chairperson at Meet Echo. Meet Echo do lots of fantastic work, namely with Janice, but they also do a lot of work with the ITF. They help stream all the ITF meetings, etc. So they really know what they're doing when it comes to real-time communication. I've used Janice a long time now, and I love seeing what they're doing with Janice and the future. So I'll let Lorenzo properly introduce himself, and I'll get off the stage. Thank you, Lorenzo.
Thanks a lot, Dave, for the introduction. And thanks. Otherwise, I can shout, no problem. Okay. I mean, long story short, I mean, I'm also Italian, so some people were wondering how I felt about pineapple on pizza yesterday. Long story short, I did feel a bit sad inside, but I mean, I'm a big boy, I'll survive. And I'm one of the co-founders of a small company based in Italy called Mitico. Many people call it Miteco because we added an extra H that didn't really belong. But I mean, we like working with real time, open source, pretty much everybody in this room. But today, I'll be talking a bit more about this big clash, and Ali anticipated a bit about that, between the WebRTC and the mock world. So for some reason, they don't really like each other. and they didn't really start on the right foot with, some bit of accusations here and there. So we did see a little bit of this in Ali's presentation. On the WebRTC side, they have strong opinions as well, and they've been going on and on about why one is better than the other, and so on and so forth, up to the point where I think they are getting a bit too far, maybe. I'm not exactly sure about that. I'm not exactly sure about that either, whatever that means. I mean, I'm pretty sure we'll get to these sooner or later. So, I mean, I'd rather, let's say, try and provide some clarity instead. So, Ali already gave a very good introduction about Quick and Mock. So, I'll basically try to keep it short about that. So, again, Quick is like, it's trying to basically take the best out of UDP and TCP and bring them together in TCP on steroids, I like to call it, but based on over UDP, so that you can do quite a lot with it, especially with built-in encryption, which is nice because it cuts down also on connection establishment times and stuff like that. And it was originally built for HTTP3, but you can really use it for anything. You can also Ali mentioned this as well. So as one of the core strong points of Quick is the ability to do multiple streams on the same connection rather than a single monolithic stream that you can do on TCP, which means that you can do a lot with prioritization and organizing streams effectively. So it really has a lot of interesting features, and you can also run it in a browser if you use web transport. So which brings us to a main point. Can we use also Quick for real-time media? And Ali, of course, already explained us that we can. But again, I'm coming in it from a WebRTC developer perspective, and we all know why WebRTC can fit the bill for real-time. And from a quick glance, it does look that Quick does have pretty much the same kind of core functionality at the very least to basically have potential to do the same thing, especially if we can run it in a browser, with some caveats that I'll come back to later. And when it comes to how we can do real-time media on Quick, of course, the first thing that may come to mind is let's just put RTP over Quick. But I mean, that can be done, but it's not really an answer because it's basically taking an existing protocol and trying to use a new transport protocol for that, which doesn't really fit the bill. Mock is much more intriguing in that sense because, as Ali said, it's really a protocol that is being conceived with Quick in mind. So try to take advantage of the foundation that Quick provides in order to do something and take it to the next level. And it's basically being standardized as a generic ingest distribution kind of protocol to do low latency, but in practice, configurable latency, again, as Ali already mentioned, which means that you can use it for conferencing, for broadcasting, or in theory, pretty much anything, with the pub-sub approach in mind, which for WebRTC developers does make sense. So it's something that resonates because we use SFUs a lot in that sense, and all with Quick very much in mind. So trying to build something that takes advantage of the multi-stream support of Quick in order to do interesting things with that. And from an architectural perspective, this is the easiest diagram that you can see. And again, very similar to what we are used from the WebRTC world with an SFU in the middle, which in Mock is a relay. And then we can have publisher endpoints contributing objects. Then these objects can then be relayed to subscribers that may be interested in them, with the added benefit that the relays can do caching for a lot of interesting things, like, for instance, the dynamic features of Mock that Ali mentioned. And of course, diagrams can get also a bit more complex than that. You can do cascading, you can build CDNs out of Mock and so on and so forth. I mean, it doesn't really matter. The core principle is that pub-sub kind of approach there. And when it comes to distributing media, it pretty much works like this, where you have typically publishers advertise under a specific namespace that has a hierarchical nature, which means that a namespace could be made of different parts. For instance, in an application, you may want to have an organization and an application, and then this is me. And these namespaces can be advertised. These will be advertised within Mock. And within the context of a namespace, I can have one or more tracks that can be added dynamically. And when people are interested in my tracks, they can subscribe to them. And there are some specific identifiers that are basically synthesized that the media coming from on this specific track alias actually relay is my audio, and so on and so forth. I won't bother you too much with the details, but this is again just to show a bit of a parallel with WebRTC in that sense. One interesting aspect of Mock is that it really is generic in terms of the media that you can distribute, because again, with WebRTC, we have a strong concept of audio and video via RTP, and then generic stuff via data channels, so two different worlds that live together. With mock, anything is a generic object. So this object can be audio, can be video, they can be encoded in different ways, can be text, it can be sensor data, it can be pretty much anything. And these objects can be grouped together. And for instance, in video, it makes sense to group objects where the first object is a keyframe and anything that follows are deltas to that keyframe, and so on and so forth. And the sequence of group is basically what constitutes a track. So a series of objects sent one after the other that are related to each other are my audio track, my video track, or whatever. And when it comes to subscribing to media and publishing stuff, there are different approaches here as well compared to WebRTC. Because with mock, you can basically do both a push and a pull kind of approach. Like, for instance, either you wait for somebody to subscribe to your stuff before sending something, or you proactively start sending stuff, and then people that may be interested in that may subscribe it later on, which is closer to what we typically do with WebRTC SFUs. Or we can also just fetch things from the past, as Ali mentioned. So basically, and the past may mean stuff from yesterday, from 10 minutes ago, from 5 seconds ago, because maybe I'm joining a conference now, the latest keyframe was 5 seconds ago. I may ask for, give me the last 5 seconds of video so that I can quickly catch up and then decode that, and then we can keep on doing stuff live, for instance. So very flexible in that regard. And the flexibility of objects, the fact that they can really be anything, means that we need to have some structure, let's say, some way to describe what those objects are, because otherwise publishers send me something and I really don't know what to do with it, which is typically what streaming formats deal with. And basically, subscribers typically need to know what kind of media they are dealing with, how it is formatted, if there is any encoding or anything like that that they need to care about. And this information can then be obtained in different ways. You could exchange it out of band completely so that mock is never involved, or you can use a catalog, as we'll see in the next slide. The main concept is that whatever the format typically gives you, eventually you end up with a specific packaging format for the objects themselves. So that if you know what packaging format has been used for a specific object, then you know how to treat it, basically. And lock is the one that I'm personally most interested in, the low overhead media container, because it's the one that is closest to RTP in vibe, let's say, in the same kind of functionality. And the catalog itself is basically a JSON object that describes all the different tracks that constitute, that I'm basically contributing within a namespace. And basically, its main purpose is, again, just to describe the different tracks. Like, for instance, I have an audio track and I have a video track. Audio is encoded via Opus. This is the sampling rate. This is video. This is the resolution. This is the bit rate. Any kind of information that may be useful for decoding purposes is there. And in that sense, it's the closest thing that we have to a WebRTC SDP, because we know that the SDP does contain the same information for negotiation purposes mostly. In the catalog, instead, it's much more declarative in nature. So basically, the catalog says this is audio and this is formatted that way. There's no negotiation aspect about it. So you need to know how that works. You can provide different options if you want to provide different codecs for the same content and stuff like that. But the catalog is pretty much declarative, but in principle, we can see it a bit like an SDP in that sense. And the interesting part of the catalog is that the catalog can be distributed via mock itself, because again, objects can be anything, and so these objects could also be the catalog itself. So maybe I connect to Relay, I'm interested in Sandro as a participant, I pull Sandro's catalog, and from the catalog, I see which tracks are available, and then I can subscribe to those tracks, all without ever leaving mock itself, which is a really interesting property. And of course, things can change when it comes to publishers. Tracks may come and go, which means that the catalog is also a live object. There can be deltas that can be sent during the session to change the catalog on the fly, and these changes are reflected also via mock exchanges accordingly. And so basically, just to do a very quick recap, I basically came up with this simple cheat sheet, if you want, about the features that we typically rely on when it comes to WebRTC and the mock counterparts. Of course, it's not really a one-to-one kind of mapping, because mock is an entirely different beast, and Ali explained it very well before. But there are some, let's say, mappings that we can make also to make them easier for WebRTC developers to understand, and easier for WebRTC developers interested in mock to know a bit how things work in terms of different things. which brings us to the point. So what can we actually use mock for? And this is I'm basically just stole Alice's slide from before, from a previous presentation, because I always like this presentation over there, where mock initially was conceived, let's try and address this specific use case, but in practice, the configurable latency aspect of mock mean that in theory, we can use it for pretty much anything. I personally see it much more interesting for broadcasting purposes. Ali made a lot of interesting demos in that sense. Then for conferencing, I still need to be convinced it will be actually a better fit. But it does have the potential of covering a lot of ground. Some people disagree a bit with that. For instance, Tsai, who is a well-known WebRTC consultant, had some opinions about that. He basically saw mock more like a solution looking for a problem rather than something that was more grounded in actual issues that needed to be addressed in specific ways. But again, that's a matter of opinion. Some people believe strongly that HLS and WebRTC cover what exists as it is. Others really believe that mock can replace them all. It's just a matter of figuring out who will be right at the end. What's true definitely though is that there is a lot of interest in mock in general. There are a lot of implementations. There's our implementation there as well. So a lot of companies, big and small, are interested in mock, at least from an interest perspective. So you have a lot of different implementations, and all these implementations interop frequently. So just yesterday, as Ali mentioned, we had an online interop session where we basically try and check whether or not our implementations work as expected. There are some more information there as well. We have a dedicated Slack channel where we communicate often in order to figure out if there is anything specific that needs to be handled. And in my opinion, the issue is not really on this side of things. So when it comes to server side, or let's say stacks and so on, we have a very good implementation available, very many implementations available. Where I do see one of the more quick points is really the client side, because we are used with WebRTC to having things easy. We have libWebRTC, especially in the browser, basically gives us anything for free. So basically, once you deal with exchanging information, negotiation information, and stuff like that, anything else, the media stack is already done for you by the browser or by libWebRTC itself. So you don't have to worry about encoding or jitter buffers or echo cancellation. WebRTC does it all for you, which makes it much easier to develop a WebRTC implementation in that sense. With mock, you're pretty much left on your own because you have to do that on your own. So you have web transport as a way to have quick access and so mock access in a browser, but then you have to implement the stack yourself. You have to decode and encode the media yourself. You have to synchronize everything on your own. You have to build your own jitter buffer and so on. And I mean, hopefully there will be implementations that will make it easier. Like for instance, Mocktail as a useful media stack that you can use for mock itself in the browser. But it is a lot of work that I'm a bit afraid of, I have to admit. So there are people that are actually happy about this because they really didn't like the WebRTC is more of a black box in that sense. So it does everything for you, but you have very little control about what you can fine tune over there. With mock, you have all the fine tuning that you want because pretty much you have to do everything on your own. Some people will be happy about that. I'm a bit less happy because I'm lazy. But that said, I am interested in mock myself. So I've been playing a bit with mock for the past couple of years, more or less. And basically all my efforts ended up in this library that I started working on that is called IamQuick. And this library started as a generic quick library that is now based on the Pico Quick stack. But basically, I ended up also implementing both RTP over Quick and mock as part of the library itself, which means that you have simpler, higher level APIs to subscribe to stuff and stuff like that in order to exchange media. That way, I implemented a lot of demos to play a bit as a test bed with all of these different protocols. Like I have a proof of concept relay, a couple of different ways of sending and receiving media, a tool for the interoping, and also most importantly, I started integrating it in Janus to basically play a bit with WebRTC to mock translation and back, because I strongly believe that WebRTC and mock are going to live one along the other for quite some time. So it does make sense to figure out ways to have WebRTC media be consumed by mock and vice versa, basically. Which is how I ended up basically implementing some demos, like an integration in Janus that would translate from log to RTP, do all the aggregation that is needed or the fragmentation of RTP packets when needed. Because with mock, for instance, video frames, you always send a single video frame on top of Quick, and then Quick handles the fragmentation for you. we all know that WebRTC, in WebRTC, big video frames need to be chopped up in multiple RTP packets. So the approach is quite different. You need to be able to reconstruct frame, reorder them, and so on and so forth, which is what I try to prototype here. There are some things that you need to handle in terms of media encoding and stuff like that. But apart from that, the media encodings are usually close enough that that you can actually do that. And so that's how I ended up doing a couple of demos. I don't know if I'll have I don't know if I'll have time to do a couple of quick demos just to show how things work. So maybe rather than showing this slide over here, we can try. Let me start a couple of things here. Just a second. So for instance, here I have, this is a subscriber that I can create. And I can say I will use the catalog here and there. Let me start a publisher. This is a command line publisher application that I wrote in mock that basically captures my webcam and then connects to a relay that I hope I started. Let me check. No, I didn't start it yet. And then now this mock publisher started, so I can try and subscribe it via WebRTC, and here it is. Basically, this is mock audio and video being sent to a relay that I have here, and then Janus is acting as a subscriber on the user's behalf, and then all the media that is coming via Quick is basically moved to RTP and vice versa. And the vice versa part we'll look at the second. So for the WebRTC to mock part, we can try and do something like this instead, where I can launch a subscriber. We can still have a subscriber over here, but instead of just doing a generic WebRTC part application, why not do something like whip? So I can basically have OBS act as a WIP endpoint. And so you may know that WIP is basically WebRTC broadcasting. So I have OBS sending media to Janus again, which means that if I open my subscriber over here, my, oh no, sorry, I chose the wrong, this is WebRTC to mock. I can subscribe to stuff here. Video will take a second to show up, and then do the same here as well. And so now I have basically two different mock subscribers getting media from the WebRTC publisher, but one is getting back to WebRTC, so doing a silly WebRTC to mock to WebRTC, and another is doing a WebRTC to mock translation again instead. So again, nothing fancy, but it is interesting for testing purposes. And so coming back to the slides to conclude, basically, yeah, there is an intering happening these days in London where they talk a lot about interesting stuff. I think that some of the topics will also touch dynamic track switching and switch, because one of the things that I didn't mention is that WebRTC has simulcast and SBC to deal with stuff. And this is something that is still technically missing in mock. And those two features will actually bring it much closer in that regard. So to be able to do different bit rates on top of the same tracks. So long story short, as a WebRTC developer, is mock just hype? I personally don't think so, but we'll have to check if or not it will actually succeed. My personal issue with that is that the working group is very active, maybe too much. I mean, the protocol changes. Anytime a new draft comes out, it changes completely what you had before, which was very different from the experience that we had with WebRTC, where you could start doing something at the very early beginning, and then yeah, things could break in change when things changed a bit, but not really up to the point where everything broke, basically. Which also explains, for instance, why Cloudflare, which is the biggest relay distribution that you have available right now, is very much behind. They are still on version 14, and we are on version 18 right now, so they haven't updated that yet. So we'll need to check whether or not people will be interested enough in the protocol to keep up with the specification and endure all of these changes as they come. But in principle, I do believe that mock is quite interesting, just as I believe that WebRTC is not going to be replaced anytime soon. I mean, it's still very easy to use, way too easy to be used for real-time media specifically, and mock will have some work to do in order to be able to basically just kick it out of the door, which is why I think that they will coexist for quite some time, and they will need to learn how to coexist for a while, and possibly also interrupt with each other, as I just showed. And that's basically it. I hope I stayed in time, and and hopefully I didn't speak too fast. So thanks.
Hello. Thank you, Lorenzo. Has anyone got any questions for Lorenzo on WebRTC/mock? No?
Was I that clear, or nobody understood
You were very
anything?
clear.
And
You were very clear.
they're too shy to ask.
So, did you hit any incompatibility in the codecs, like B frames and stuff like that, that you had to re-encode before you put it into WebRTC? Like, did you have to re-encode it in the middle?
No, I mean, in principle, I mean, this is not really an issue because it really depends on how people, considering that an object can be anything, people can choose how to encode media. And basically, so far, I was mostly either relying on how WebRTC did things and how I encoded things myself using FFmpeg stuff, or tinkering with mock encoder player, which is an implementation by Meta over there. And when I first started implementing the gateway there, one issue that I encountered was that mock encoder player was using web codecs. They encoded H.264 and then formatted it using ABCC, which is not really the way that WebRTC and RTP packs H.264 instead, which uses a different format called Annex B. So in that sense, I didn't really have to transcode anything, but translating those H.264 formatting that I needed to do, which is much more lightweight than having to transcode anything, because you just have to replace some bits here and there where nulls are separated, but still something that you needed to take into account. And of course, the moment that I want to gateway between mock that uses, for instance, CMAF or other ways that media can be formatted, the work there there could be more work to be done there, because media may be chunked differently and in a way that is more incompatible with WebRTC. What I really wanted to highlight was that there is a way to bridge the gap between the two. It will be a bit trickier when you want to handle also fetch or synchronizing stuff and stuff like this. I don't think it will be impossible. I think there are ways to hack things around so that you can have the same effect on both, but still a bit of work will need to be done there.
Lorenzo. Right. Everyone give Lorenzo a round of applause. Thank you.
Thank you.
Okay. You've got far too long a hair for such a microphone. Next up, Tim Panton. Tim Panton needs no introduction, but I'm going to try and give him one anyway. I think I first met Tim at an Astrocon back in, I think, 2012. I think it was my first Astrocon.
Which one?
Atlanta, I think it was.
Yeah.
I think it was the first Atlanta that I went to, and then there was a second Atlanta back in the days when Astrocon was really great. Yeah. And Tim was this wise person. I was a web developer who knew nothing about VoIP, and Tim was like, "Oh, yeah, no, I get it. There's VoIP, and then there's this new stuff. We should be concentrating on the new stuff." Are you ready? Do you think?
Maybe.
Maybe.
We'll find out.
Okay.
Yeah.
I'll let Tim introduce himself properly. Everyone give Tim a round of applause. Thank you.
So yeah, I'm not going to live up to the wise thing. I've got into the point where I basically tinker with things these days, and some of them are really interesting, and some of them are kind of just confusing. So yeah, right. So this is about what's new in WebRTC on the wire. So basically, I'm going to talk about some draft RFCs. See what maybe you can do with them. So a little bit about me. Tim Panton, I'm the CTO at BI.PE GmbH Pipe. I wrote a WebRTC stack a long time ago for small cameras, and it sits in like baby monitors, but more recently it's been in race cars going around tracks at crazy speeds, all around the world actually, which is kind of weird. So a little bit of context so you know what kind of where I'm coming from on this, and that is actually our camera. So I'm particularly interested in P2P. So in this particular case, it's track to pit over 5G. But so it's kind of one-to-one. We're not doing wide distribution of this video. And likewise with baby monitors, it's effectively one-to-one or one-to-two possibly. So we've got our own WebRTC stack, which means that we can mess with stuff kind of arbitrarily as we like. We don't have to get sign off from anybody else to do this. And I'm very interested in dynamic web network quality. I mean, if you look at these things moving under bridges and whatever, you get huge variations in the available bit rate. And the other thing, though, is that these things move quite fast, and so you want low latency. So there's a kind of interesting set of challenges there. And then the final piece of context about me is that I'm a member of the W3C WebRTC working group, so I get to see what's going on in that space and contribute to it. And I'm also a relatively active IETF participant, less so these days, but for actually reasons that become clear in a minute, but still quite active. So if you look at what's been happening in the WebRTC space for standards, you know, pretty much the W3C who define the APIs have been constantly updating, tweaking, changing the APIs, adding things, clarifying stuff continuously since the beginning of WebRTC. That's been a pretty much continuous process. Whereas the IETF pretty much stopped. About, I don't know, maybe 10 years ago, the wire protocol solidified. And at that point, as Lorenzo was hinting, there was like pretty much no change since then. There have been some detailed changes, but very little. And I mean, arguably, that's a really good thing because it allows people like me who are writing and Lorenzo who are writing WebRTC stacks to build something that's reliable and then just keep it there. But recently, there have been a bunch of interesting developments in that space, and that's kind of what the rest of the talk's about. So the first one is actually not strictly a WebRTC thing, but it's relevant for WebRTC, which is L4S. So the kind of overarching RFC for that is 9330, but there's a bunch of sub RFCs as well. And what it gives you, what it's aiming to do is to give you the ability to do low latency and low loss and scalability all at once, which is kind of, traditionally they're a trade-off, and this is hopefully allowing you to make that trade-off more intelligently and get a better result out of it. And it essentially just uses 2 bits that are sitting underused in the IP header, and it allows you to do congestion, well, actually not congestion, buffering, detect buffering in a network more reliably and at low latency. And basically what happens is that the sender of a packet sets an ECN bit which says, I'm interested in you telling me what's happening to this packet. And then in the path through that, the network equipment that packet passes through does one of 2 things. It either immediately passes the packet on unchanged, or if it has to buffer it, then it sets I buffered this packet bit, unless it was already set, in which case it just leaves it. So, and then the receiver of this packet at the far end of the connection gets this packet and says, hey, look, it's got that bit set, or it hasn't, and it collects stats on this, and then it sends it back to the sender. And the sender can then moderate its stream depending on how many of those bits have turned up and in what state. So, and this is actually getting rolled out in quite aggressively by some interesting people. Like this is Ericsson's diagram for how they're doing it in 5G. And one of the things I want to point out in this is that the feedback comes in 2 directions. It's not only the queue, but it's also actually in this case, it's effectively a mobile phone. The mobile phone has input into whether this package is going to get marked or not. So it's an interestingly complicated solution they're coming up with. Sorry. So in the context of WebRTC, basically, in order to take advantage of this, what you have is you need to implement support for a new RTCP element, and this is spec'd in RFC 8888. And to use it, you just basically have to set a flag in Chrome which says, hey, I want to use this because it's experimental at the moment. And then you have to, in your server or wherever, you have to consume this RTCP and do something sensible with it, interpret it in a way to manage the flow that you're sending. Unfortunately, but anyway, Alphares's support is patchy in network, so not all network equipment knows what to do with this bit, or these 2 bits, and kind of doesn't matter, provided that the thing that's in front of the choke point on your network supports it. Then it doesn't matter whether the other things do, because the chances are they're not the thing you're worried about. But if there's a bottleneck somewhere in the network and you are monitoring the queue just before it, that's actually really useful. The other buts are that turn and VPNs strip or hide those bits, because effectively you're encapsulating the packets, and so you lose visibility on parts of the train, which is unfortunate. And then the interpretation of the stats is non-obvious. Like I think that's still a developing field. I have opinions, and one of them is that I think that the way to interpret the stats is probably even codec specific. We're going to find that out, hopefully. I'm going to try and get some experimental stuff done over the summer. So just to see what the kind of aspirations are for this, these are some aspirational graphs, and basically on the left you have classic sawtooth bandwidth estimation, where it's kind of bumping up against the limit. And then on the right, you have bandwidth estimation with L4S, and it's bumping up. It gets to the peak faster, and it stays there, and there's only a very small oscillation along the top, and it very quickly detects the sharp drop in available bit rate. And I think that's where we would all like to be. I'm not sure it's realistic yet, but it's at least theoretically possible. So next set of and these are 2 separate RFCs, but I'm going to take them together. So there's SIP and SPED and SNAP, and they're basically about speeding up the WebRTC connection. And one of the things that's kind of a bit of a downer for WebRTC is how long it takes to bring up a connection. And essentially, WebRTC setup is a protocol waterfall. Right? You know, you do offer answer, and then you do an ICE path, and then you do DTLS, and then you do SCTP, and then you do DSEP. And in the end, you get your connection. But that's a lot of round trips. In fact, it's 6 round trips. And so, like, what SNAP and SPED do is to reduce that. But they kind of go against the original design decision. So kind of 10 years ago or more, we tried to simplify WebRTC standards process and the security analysis, arguably, and the implementation and testing by using a bunch of protocols that were already well defined, well written up, and just kind of layering them, and then keeping the layers as separate as possible, keeping very kind of clean interfaces between them. And basically, SNAP and SPED are layer violations. They basically smoosh the protocols together to try and accelerate the startup. So what SPED does is it embeds the first DTLS exchange in the ICE handshake. So as part of the ICE handshake, you are actually carrying the DTLS hello as one of the bits of the ICE packet. And you know, it defines 2 new attributes in stun, and actually this is what happens. You just push these things out of the way and into the ICE exchange. And then Snap does something similar, but kind of arguably worse. It takes the SCTP in it and embeds it in a new SDP attribute. So it pushes it all the way up into the offer answer. And the value, so it defines this new attribute, and the value is basically the base 64 encoded value of the SCTP's init chunk. And it also says, well, hey, look, because we've got DTLS and ICE, we don't need SCTP cookies, so we'll skip that stage as well. So it actually takes out takes out 2 round trips and quite a few packets. So I did an experiment to see if this works, and you just enable it in Chrome, and there's a GitHub repo with my test code in it. And basically, you get a connection 90 milliseconds sooner and some 10 plus packets fewer. And in fact, you can see here you've got the embedded hello in an ICE packet. So it does actually work. It does what it's supposed to say, and it does speed things up. You get fewer packets on the wire. There are some downsides. SPED assumes that you're using a specific DTLS in a quite specific way. It assumes that you're using DTLS 1.3 and or that you're using DTLS flights, which you kind of group packets together. If you don't, you'd get a lot less benefit. And it assumes that you're not using RSA certificates because they're too big. They don't fit in ICE packets. And so you lose a lot of benefit there. And Snap, in my view, needs somebody to do a pretty serious security analysis on it, because I think it may leak something that it shouldn't, but I can't see what, to be honest. So support for SPED and Snap, it's in Chrome, in Canary, behind a flag. It's available in Pion, and I'm testing it in Pipe. And feedback to FIPO on this repo, and I think there's probably going to be a discussion at IETF 126, kind of talking through this and trying to codify it. But yeah, it works at the moment. So the next thing is WEP. So WEP is it's standardized signaling, right? We were never going to do that, but look, there it is. For a specifically relatively narrow use case, so WebRTC egress, i.e. streaming effectively, you know, kind of mock territory almost. It's the companion to the successful WIP protocol, which is for ingress, which is already an RFC, but it's a little bit, Dan maybe has some feedback on this, but it's a little bit stalled at the moment. I think partly because there was a requirement to do SDP offer from either side, and that makes the protocol a little bit more complicated. And instead of just stealing the words from the WIP RFC, one has to write new words and agree them, and that takes time. So the final thing is actually not ITF exercise. It's taking place in the W3C because it's an API rather than a protocol. And RTC transport, as we're calling it temporarily, I'm not sure if the name will stick, is essentially a rawish UDP packets on the wire from the browser. And there's a GitHub where you can discuss this and find the designs and whatever. But basically, it's trying to offer you P2P, and that's important, peer-to-peer datagrams between two browsers. And it allows JavaScript to control the content and the pacing of those packets almost completely. And the idea is that it's for kind of niche situations and protocols where the RTP standardization process is too slow. So it's a codec that you can't get support for, or it's not native media or something like that. Or where you want to customize the pacing and congestion control in a way that, you know, the WebRTC black box doesn't do. It imposes encryption and ICE and a circuit breaker, but actually pretty much nothing else. Like the rest of the WebRTC stuff is not imposed on you, so you're free to make your own mistakes as much as you like. And again, the prototype is available in Chrome. So just to kind of put it in context of what it will do that other things do or don't do, you know, if you look at Web Transport recently acquired datagrams, which was like literally this year. It used not to have them. You pretty much don't get bandwidth estimation from Web Transport. You can't customize the congestion control within the browser. I mean, if you go and write seed code, you probably can. And it doesn't support P2P. But it will support arbitrary codecs because essentially everything's just an object, and what you put in the object is your problem as a developer. So WebRTC kind of is almost the polar opposite of that, in that, like, it does datagrams. WebRTC RTP effectively does datagrams, it does bandwidth estimation, does custom congestion control, but arguably very much video centric. It does P2P, although a lot of you don't care about that, but I do. But the big blocker is it's very limited in the codecs it supports. And the data channel kind of does the same kind of problem as web transport, in the sense that, like, there are things that you can't control the bandwidth estimation, you can't control the congestion control, like they are fixed behaviors, but that it does do most of the other things one might want. So the idea with web transport is to try and get as either a yes or it's your problem line, and it pretty much achieves that. So I thought I'd do an example of to test this theory out, because this is kind of pretty much the way I work. And I can read a standards document, but to work out whether it works or not, I actually have to build something. So I built a use case, which is this LiDAR. This is actually a small industrial LiDAR, but you see them in cars and stuff, and robots and stuff like that. And it's think of it as like, you know, those submarine sonar things. So you just get a sweep and it tells you how far away the enemy ship is, that kind of thing. It does that only a lot faster, and it does it with light rather than sound. And I want to the experiment is to try and view that in a browser at low latency, peer-to-peer. Now, I did a similar thing to do this in the data channel, and I got bogged down in congestion control. So it's kind of interesting to see whether this will work. So a little bit about LiDAR data. 1,200 byte packet, and each packet covers, like, I don't know, about 30 degrees. And the packet contains a timestamp and an angle, and you get like about 88 packets per sweep, because this thing doesn't look behind it, as you'll see in a minute maybe. And it's 30 scans a second, so like 30 frames a second effectively. So it's 240 packets a second, but this is only a single line. One in an expensive car will have 64 typically stacked mirrors, essentially, so that it gives you a not just depth but also a kind of height image. But the important thing is that this is a non-standard format, right? There's no RFC for these packets. There's a document that you get from the manufacturer, and that's it. And so there's no codec support in RTP. So just a little bit about that. It's 2.4 megabits a second for this single line one. The packets don't care about the ordering, because they have enough data in them for you to know how to render them without seeing any of the others, with the slight exception that you can't measure speed towards you as easily. And the flow is choppy because there's a gap at the back. So basically you get packet every 3 milliseconds as it's going around, and then when it gets to the back, it stops for 8 milliseconds. So it's quite a sort of jittery flow, which messes up conventional congestion control and pacing quite badly. So I'm going to do a stupid thing, as usual stupid thing, and try and demo this. So what we have is this little LiDAR plugged into my laptop, and then we have we will run a Java proxy, which proxies between the LiDAR's constant stream of packets and an RTC transport. So we're getting our 200 and something packets a second. And let's run a Chrome with the right flags, which you probably can't read, but no matter. So we've got Chrome here, make it a little bit bigger. and warning me that I've done an unsupported set of flags. And we do connect, and with any luck, yeah, we get an offer answer of sorts. And then with any luck, we'll actually get some data. Yeah, there we go. So this is the room. You can see, it's actually deeper than my, that's funny, the room is deeper than my circle because it's further back than my office. But yeah, you can see the shapes, and like you can see my hand appearing or blocking off the data. And like maybe if somebody raises a hand, we'll see the hands. Yeah, there we go. They are all there. So like this is live data over RTC transport in Chrome from Java. So it's kind of in, and the interesting thing that's worth saying about that is that it's just basically DTLS on the wire, but sent from the browser. So I want to summarize what I've just said, which is that like new stuff is happening in a way that hasn't been happening for 10 years. Like this is, the logjam has been broken. The new APIs and protocols are emerging in the WebRTC and WebRTC adjacent space, and they play to WebRTC's strengths, which are peer-to-peer and end-to-end and dynamic bandwidth management. And I think that's really interesting. I think that's the space that Mock is not going to move into. It's not interested in peer-to-peer. It's not interested in highly dynamic bandwidth environments, as far as I can see. And so what we're getting is consistently low latency, faster setup, plug and play signaling for WIP and WEP for streaming, narrowish use case, and low-level packet access for those of us who want it. Which I admit is a small minority, but there's some interesting use cases coming along, particularly in vehicles, moving things. So yeah, that's pretty much all I've got to say. Image credit was from the Dubai 24-hour race. I should credit them with that. And there's a ton of other pictures of cars in that gallery. Yeah, I'm a little bit deaf, so you might have to shout if you've got questions. And yeah, contact me, Tim Panton, afterwards. Steely Glint on Chaos Social and the Fediverse. Yeah, that's it.
Has anyone got any questions for Tim? Sandro.
For the part where you described the changes to the setup, you mentioned that there needs to be a security, review. Do you have anything in mind? Do you have any particular concerns, or is it just, general, hey, we're changing the way that things work. They worked fine security-wise, sort of, but, we might introduce new things, or do you have specific, net points?
I wouldn't go as far as saying specific, but I think the piece that makes me edgy is that this data in the SCTP init was previously wrapped in DTLS and wasn't visible to the JavaScript, and it wasn't visible to the middle boxes. Whereas in the SDP offer, it's visible to the middle boxes and it's tamperable with JavaScript. Now, arguably, FIPO assures me that it doesn't matter, that these things are not interesting data. And I tend to agree with him, but like I think somebody needs to stand a bit further back and say, well, hey, there is a use case where you can do a denial of service from JavaScript because. And I don't know what those are, I don't know what that is, but it's exposing data that wasn't previously exposed to places that couldn't see it before.
Yeah, thanks.
Any other questions? No? Thank you very much, Tim. We'll be back in 25 minutes. Oh, yeah. Thank you. We'll be back in 25 minutes. Go get some coffee. There's some croissants and things. We'll be back for security and identity. Yes. Be back in 25 minutes. Hello. If everyone can come sit down, that would be great. Right. There's an HDMI cable for you. I'll give you that. No one's needed an adapter yet.
Yeah. Hopefully it won't be me. Yeah, good. All right.
Do you want it mirrored? Or
No, no,
you okay?
I'll try this. Where are we? Where's the mouse? Yeah. Full page.
Good?
Yep.
Ready? Great. Right. Sandra's going to kick off the next section. Attacking WebRTC conferencing. If you haven't already, you should definitely, he's probably going to shout it out in his talk, but you should definitely go and subscribe to his mailing list for future updates. They are fantastic. Every month, aren't they? Every month. Sandro knows his stuff when it comes to security. Yeah, I'd say so. But yes, I'll let Sandro introduce himself. Everyone give Sandro a round of applause.
Thanks, Dan. Very kind. Okay. So, welcome to my talk. It's called Attacking WebRTC Conferencing, but it really is about a new scenario or lab in new project of ours called the VRTC, or DEM Vulnerable Real-Time Communications. And I'm going to go into a bit of the sort of vulnerabilities that we've seen during pen tests and how we implemented them in this project. And it will also have to do a lot with access control in a WebRTC environment. All right, what we do, I'm Sandro Gauci. I run Enable Security. We do pen testing. And might know me from SibVicious, which is a VoIP security toolset that's been pestering the internet since 2007. So let's start with a demo. I'm going to keep this brief. Before I start the demo, I'm going to just describe what we have. So in the middle, we have the target. There's two components. There's a front-end app called Blue Pill Meet, which looks a bit familiar, actually. And in the backend, there's a Janus backend. On the right, we have two bots, Neo and Morpheus, who are having a private video call in a dynamically generated secret room. But it's happening every 90 seconds. There's a new video call, so they're hopping around. And on the left, we have the attacker. And the attacker does not know the room ID or the secret WebSocket URL for Janus. But the attacker can create a new room, just like many, Meet applications, Google Meet, Jitsi Meet, stuff like that. They all allow you to create a guest room. So this is very similar. So if I find out where my mouse went. Start video. So I'm the attacker, and I'm gonna create a room. This is me in my office. I recorded this. And there's the network traffic, and you're gonna see, as usual, you're creating a room, so there's going to be some REST API calls. And eventually, when you create the room, it gives you a Janus WebSocket. And you're going to notice, maybe in the back you might not see it, but it's a unique URL with a randomly, securely random ID in the back that is properly checked by the application, by the front end. And then once the browser then connects to the WebSocket service, which is Janus. I've copied and pasted that URL into my tool, which is the Janus operator. It's running on 1270 on localhost. And I'm going to use that directly from this tool, which then allows me to list all rooms, join, subscribe to the video streams and audio, send my video. Of course, I'm going to use the bunny video, and kick people, destroy rooms, whatever it is, right? All the Janus sort of commands that you can run. Now, this is not a Janus vulnerability, okay? Just to be clear, because I think Lorenzo is going to get offended otherwise. This is the way that the application uses Janus and the way that Janus is configured. It's a combination of both. But, this is something very similar to what we've seen in one of our recent pen tests. So, it's a very real scenario. So just, the diagram basically shows, that the attacker and the normal user pass through the same route. It's just that they're doing different things, essentially. There is no bypass. There is no secret path, secret REST API call, or anything that is, allowing the attacker to pass through a different route. It's just the same flow, but when you use the app, it implies that there is a room boundary, and the app does, the front-end app, the Blue Pill Meet, does actually separate these, does access control through this unique URL. But once you connect to the unique URL, you get the same Janus, which is not configured to enforce any security in this case. So, and anyone can get this unique URL, which is what we've seen with our client. So then, rooms are listable, and yeah, you can subscribe to video streams, kick people, destroy rooms, whatever it is, right? I'm not saying that you can't fix this, but it's how we saw it with our client, and how we implemented this. So yeah. Now, usually I would say, okay, the lesson to learn is that, signaling should also be an authorization boundary. You apply security at signaling level as well, all throughout, right? so that, if you're as a user, you're not supposed to list the rooms, then you enforce that at signaling level as well, at the Janus level. If you're just forwarding Janus traffic, WebSocket traffic in this case, or you might have a proxy that does this. But usually you would have no way to reproduce this easily without building your own app. But that's why I'm going to be showing you the VRTC, which is our project. So the reason why I showed this demo is to show you that this is not, this is not a one-off stunt. We have a scenario in DVR2C, this project of ours, that is freely available, that allows you to reproduce this with the attack tool as well. So you have best of both worlds. But what is DVR2C anyway? So it's a set of deliberately vulnerable RTC labs, voice over IP and WebRTC security labs. And the name them vulnerable comes from the cybersecurity world, where there are a lot of projects which start with those two keywords, like the VWA, the them vulnerable web application, which has a set of PHP scripts that are, have various vulnerabilities that many people in the security community learned from and practice with. And yeah, we started with, we for a long time, we needed a server to test against, to test our security tools like Subficious against, to make sure that they are working well. And this is how it started a couple of years ago. But now we have been implementing this and making this public. So that's the difference. So we have different scenarios. We have PBX1, and which is made out of Camellia, Asterisk, and so on. What I'm talking about, and there's PPX2, which with OpenSIP's pre-switch. But what I'm talking about here is the conferencing one scenario, which is still works in progress, but you can use it already. So you can go on GitHub and try it out, or you can try it out also against a live system. We spun up a VPS and run it there. So go forth and abuse. Of course, you should only run it in isolated and dedicated systems, because otherwise you might run into trouble if you run it on your enterprise network. So what we have in terms of architecture right now is, it looks like Google Meet or Jitsi Meet, very familiar, but running Janus, because we wanted to try that out using the WebSocket signaling. You're gonna just use Docker Compose to bring up the whole stack. It's very simple stack, and we will be adding more. For example, one idea is to add a note-taking bot that joins the room when you ask it to, with a headless browser. And there's various vulnerabilities that we could introduce there. It's it's an underappreciated area. Now, and we have these vulnerabilities already in place. The one that I showed you, we're calling it signaling abuse, where you can do all these things that I showed in the video. Cross-site scripting, of course. This is a very standard web application vulnerability, but with a WebRTC sort of component where you could use cross-site scripting to hijack media permissions, for example, if the users have already clicked the "Don't bother me anymore" button. But these are still works in progress, and something that we've seen in practice some years back during a pen test is signaling channel hijack, where the attacker could specify which signaling server to use, and this could be also interesting. So yeah, what's next? Add more vulnerabilities. So I'm interested in getting ideas from you guys. So all the scenarios that have been released, gotten through the release, they have proper exercises, they have proper automated tests to make sure that they still work, the vulnerabilities still work, which is probably the opposite of what you want in a live environment. But in this case, that's what makes sense. So yeah, we still need to do that for the new scenario, for the new lab. But yeah, contributions are welcome. Issues, open issues. If you try it out, I'm sure you'll run into trouble because we don't have enough users. It's a very new project. But I hope it works for you. One more thing, the newsletter that Jan mentioned. So every month we issue this newsletter, which kind of tries to include a couple of things, right? We cover voice over IP and WebRTC research that is done by third parties and us, of course. So we pitch our stuff as well, but there's the majority is what's going on, and you'd be surprised how much is going on in the WebRTC and voice over IP security world. So if this is your area, and I think you're in the right place, then please do subscribe. It makes a lot of sense. And yeah, we have top secret URL that you can QR code scan, and there you will find the slides and the videos and all the links and so on and so forth. And if you want to try it out without running anything, just go to conferencing1.vrtc.net if it still is up. I didn't check. That's it. Thank you.
Has anyone got any questions for Sandro? No questions? Well, thank you very much, Sandro. Right.
Do I get her the this? You can go. Thank you very much.
A MacBook without an HDMI. Space. There you go. What do you want? White mirror. Yep. That's the one. There we go. And just click Mac. Yeah. this. No. Do you want to try your adapter? Or you okay? Yeah. Aha. Backup plan. Backup plan.
Long hair is not that easy.
No.
Lorenzo, you understand me.
It does not like that adapter. Just shout. Okay. Right. Ready? Okay. What? The mic. Do you want to speak for? Is it? Yes. The screen's on. Yeah. That should just work. No. No.
Anything better now? If not, I just need to find my hands and follow her out.
Or I can stand here.
Okay. We can try.
Working? Not working? No? Okay. Do without. Sorry, hair. Right. Okay. Everyone,
Okay.
Ariana.
But now everybody can hear me. But the presentation vanished. Okay, this is a hard start. Maybe. We'll try. Again, just scream, stop. Stop, Ariana. We don't see what you're talking about. Okay. But that being said, let's start. So yes, I'm Ariana and I work for Select. And today, if you can see, we're going to talk about real world use cases of blockchain in telecom. But just a disclaimer, this is not going to be a theoretical blockchain presentation. I'm still checking it's there. This is going to be about actual implementations and what we learned while we implemented blockchain in telecom. So now we just need to go. I'm so sorry that this is like this. Okay, so Select, as I said, is the company that I work for, and we are an MVNO, and we have more than 20 years of hands-on experience in telecom. And Arnacon is a startup in the Netherlands, and we took that experience in telecom and applied it to blockchain. And in the last 3 years specifically, we really focused our attention on blockchain and tried to explore it more persistently. And that means we looked at many different scenarios and at many proof of concepts. And we can tell you what works for us so far and what we learned. I feel like the moment I touch the laptop, everything vanishes. And you know, I'm German. Usually I'm perfect here.
I was going to make some jokes today.
You were too slow. Okay, now let's try. Where are we now? Yes, that works. Okay. Select's main goal basically is to utilize the advantages we get in blockchain and apply it to telecom. And let's have a look what that looks like. We're going to discuss 5 use cases, and these use cases in this presentation are not guesses, so kein Wunschdenken here. These are cases we tested and implemented. But these 5 are not the only possible use cases of blockchain and telecom. They're only the 5 cases that we consider to be the 5 most valuable ones. And for each one, I will talk about 3 things: the traditional implementation, the improvement we implemented, and finally, where the magic is. Let's start with something that every telecom service needs, and that is notifications. In a traditional mobile app, the push notification, so the small alert that your phone receives from an app, even when the app is closed, that normally requires a backend. And this backend prepares the messages for APNS or Firebase, but the sensitive part is that the credential for the push certificate, they need to live somewhere. And usually that means a company server. But this company server or notification backend becomes another system that needs to be secured and monitored and maintained. But in our implementation, the secured blockchain network Oasis handles this sensitive preparation step. Let's be clear, the blockchain does not deliver the notification. Apple and Firebase still do that. But the important part is here that we remove the need for our own notification backend entirely. So from our application perspective, there is no company notification server in the middle anymore. So the certificate is hidden in Oasis and can be used by the client without exposing it or revealing this information. And for telecom, this matters because every backend adds cost, risk, and monitoring, and all of these things that we actually don't want. But with the just introduced approach, it means we have less infrastructure, less backend exposure, and a better privacy posture. And all of that because there is no company notification server in the middle anymore. In short, we are decentralizing delivery, but we are not decentralizing delivery, but we are decentralizing the sensitive preparation step. And let that sink in for a moment. What you need to remember here is simply there is no backend. But now to the next use case, which is about activation. Can activation work without direct integration into a seller's backend? Service activation usually requires integration with the seller's backend or a billing system, coupon system, or purchase database. And that works, so the problem is not that activation is impossible today. Rather, the problem is integration. Every seller and provider, store, etc., everyone may need a different connection before the app can verify that the user is eligible. And before we move on to the solution we propose to this hurdle, it is important to have an understanding of what ZKP, so zero knowledge proof, means. A simple way to think about this is a wristband at an event, like you can see here in the image. You buy a ticket before the event even starts, and you receive a wristband in return. At the entrance, nobody needs to check the full payment purchase database. the wristband proves you're allowed in. In our implementation, the wristband is a cryptographic proof. The seller confirms eligibility once when the user buys the product, and then the user receives the proof of purchase. Later, the app verifies that that's proof that the user received, and the client does not need the direct access to the seller's purchase database. The client does not need to see the full purchase record. So instead of asking, let me check your full purchase data in my database, the service can ask, show me proof that you're entitled without showing me everything. And that is the important shift here. Purchase and activation are no longer are linked through proof, not through direct backend integration. And that means the app does not need a custom integration for every seller, provider, or campaign. And that is important when products are sold through different channels. The seller also does not need to expose its database. The client only verifies the proof that the user brings. So we still get private onboarding, but the bigger point is flexibility. The user proves eligibility, the service verifies it, and activation can happen without revealing the full purchase record or connecting directly to the seller's backend. And now let's have a look at a short demo of this proof of concept, proof of purchase concept. So we are right now on the provider's store or website where you can choose and select your product that you want to buy. And then we're going to pay with the provider's preferred payment method. And once the payment is received and everything went well, crossing fingers, we get a QR code. And this QR code is our wristband, if you remember. That's the proof. We bring that proof, so the client brings that proof to a completely unrelated client application to activate their product. There's no connection between the service provider website and the app that you see here, which, by the way, is the Arnacon app. And we can immediately use the product. So the demo shows a user buying a virtual Israeli number, just to be specific. I was too fast. On a provider website, after purchase, the user receives the proof and then brings it. So the important part is not the UI itself. The important point is the separation between purchase and activation. And again, what you need to remember is there is no backend. So after this use case that we just saw, use case 2, we can prove that someone bought a product, the virtual Israeli number in this case. But telecom products are not always one-time objects. They expire, they renew, they change state. A number may be active today and expired next month. But today's subscriptions usually live inside a provider database. And inside one provider system, that is fine. The provider knows who the user is, which services are active, and what status each subscription has. But the problem starts when another service, app, provider, etc., needs to verify that status, because then you usually need an API integration or database access or some other connection to the provider's internal systems. And again, before we move on to the next slide, a quick side note for those who may not know what ENS stands for yet. It stands for Ethereum Name Service, and a simple way to think about this is like DNS. So DNS gives us readable names to technical internet addresses, and ENS gives us readable names to blockchain identities and records. And for telecom, we use this as an identity and subscription layer. Meaning, in our implementation, ENS acts as a readable identity layer. A record under that identity can represent an active subscription, product, or service. And like you can see here on the image, can you see my mouse? Yeah. Here we have a list of products. Each product in this list can represent a different service or even operator. For example, one product could represent a prepaid package, another could represent a mobile subscription, and so forth. So the point is that the subscription is no longer hidden inside one internal provider database. And this makes subscription status easier to discover and verify. Services can verify relevant records without depending on one provider's CRM or billing system. And as a bonus, the user gets a more portable identity. So instead of asking, can I access your internal subscription database, the service can check a shared verifiable identity record. While use case 2, so the proof of purchase use case, proves entitlement of activation, this use case 3, helps verify ongoing status. In other words, we're now able to check whether the product we purchased and installed in use case 2, I remind you the Israeli virtual number, whether that is expired or valid, even though we do not have a direct integration with the provider's system. And that is the magic here. Now we have 3 rings. So far, the pattern is clear, I hope. Remove backend dependency, separate purchase from activation, and make subscription status verifiable. What you need to remember here is there is no backend. And that is not just slide architecture. In October 2024 in Amsterdam, we competed at the Ton Society Hackathon and placed 3rd with an early version of this idea. As you can see, we are not claiming to be experts yet, hence 3rd place. But we've already built in this direction, and we keep getting better and discovering more things. And yes, I know what you might be thinking, not just the team is small, I'm also quite small. But let's focus on our next use case, where we asked, what if the website itself does not need a backend? Think of a reseller self-service portal, a place where a user can log in, check service status, activate the product, or configure something else. In a traditional setup, the portal depends on backend servers and databases. But in our implementation, the website is only the interface, a site that runs entirely in the browser. That means the state does not live in a server database. Instead, the state is read from and written to a blockchain. So the user interacts directly from the browser. And yes, you heard that right. The browser is only the interface, and the blockchain becomes the trust and state layer. So we have no company application server in the middle. That is the important part here, because people usually assume there must be a backend somewhere, but there is not. No application server, no operational backend. And the practical result of this is we have a lower operational burden, less backend maintenance, and that the state is directly verifiable from the network. And if that's not magic, honestly, what is? And again, what do you need to remember? There is no backend. So if we can represent service state this way, the next question is just as important. Can we represent ownership or routing state for telecom resources like phone numbers? Mobile number portability is a coordination problem. Several parties need to agree on the current state of a number. And the key question is simple. Which operator currently serves this number? Today, that coordination depends on operator processes, regulators, and centralized, yeah, you guessed it, databases. That can make the current state fragmented. One system may have one view, and another system may have another view. So the issue is not only technical, it is about creating a trusted, shared view of the current state. But with blockchain, the current serving operator and number status can be represented as a shared verifiable record. You could think of this as an NFT, but the better explanation is it is a verifiable ownership or status record. That means a number can have a current owner, a current status, and a shared history that authorized parties can verify. That means when a number moves from one operator to another, the shared state is updated very easily. And the value is that everyone who needs to verify the current state can check the same source of truth, the same. And that can reduce dependence on one central portability database. And it can make coordination easier between operators and authorized parties. So this is the last time I'm asking this. What do we need to remember? No backhand, exactly. Across these use cases, the pattern is the same. We are not moving telecom traffic to blockchain, but we are moving trust, ownership, entitlement, and coordination to a shared layer. We saw in use case 1 that removing a backend from one technical function, so the notifications, is possible. In use case 2, we saw that removing direct integration between purchase and activation can be done using the blockchain. In use case 3, we saw that making subscription status independently verifiable is doable as well. Then in use case 4, we saw that removing the operational backend from a whole portal is doable. And just now, we saw that moving coordination between operators to shared verifiable state can be done as well. And that is the whole point here of blockchain. Not voice packets, not media, not radio networks, but trust and state. And this also tells us when blockchain is a good fit and when it is not. Blockchain is useful when multiple parties need to agree on state. It's useful when no single provider should fully own the system, when users should control their identity, when entitlement should be verifiable, and it is useful when the record should be portable. And most importantly, in a way, is useful only when the business logic can be expressed using blockchain, because if that's not possible, then yeah, it's not useful. But these points, they match many telecom adjacent problems. So subscriptions, verification, identity, etc., etc. But having said that, blockchain is not a magic telecom database. Some things are better kept off-chain. And that means, for example, hosting real-time media or streaming voice packets, or when handling large private data. In these cases, blockchain is not a good fit. Essentially, blockchain is not very useful when handling anything that needs high speed by default. That is because blockchain transactions are slower than traditional database operations. And some interactions, they also have a cost. And this is why the architecture matters so much. We keep telecom networks doing what they're good at and use blockchain only where shared trust is actually useful. So the summary is quite simple. We are not replacing telecom infrastructure. We are only improving the flow and processes in telecom using blockchain. What these use cases should have made clear is that building infrastructure for a decentralized and private telecom service model is possible today already. We no longer need to depend on centralized servers and private databases. And that is the future telecom stack we are working toward. This future telecom stack can combine two things: traditional telecom reliability for connectivity, routing, and service delivery, and the blockchain-based ownership, identity, entitlement, and trust for coordination. And that is where Arnacon is focused. I remind you that's a startup. Telecom applications that are easier to deploy, more private, less dependent on centralized servers, and more user-owned. Thank you, and I'm happy to answer any questions.
James, do you have a question?
Yeah, first of all, Ariana, that was an absolutely outstanding first ever presentation. So well done on that.
Thank you very much.
I am blown away by the cleverness of this, and I'm really interested to discover how the concept could be integrated into some of our smart SIM technology, using the SIM as a root of trust or something like that. Can you comment in, well, 2 sentences about that?
I think we maybe should talk about this also afterwards, but there's definitely a possibility because the Arnacon app, it's for everyone, this is more supposed to be like a app store for telecom services. So every operator or service provider could come and offer what they want, how they want it. So if you would like to have this added security layer using blockchain, then we could definitely talk a bit more about this afterwards.
Tim.
It's really interesting stuff. I wonder how it copes with the kind of real world of regulation, things like know your customer and you can't sell this SIM in that country and all of those kinds of legal tedious things. Have you started looking at that?
We're trying to avoid the know your customer as much as we can. And that's not supposed to sound very sketchy, but when we go back to the demo video that I showed, that's just one example of it. But the only thing you needed to provide is the payment details. You didn't need to give your name or anything more specific than that. And you got the product. So it's more about, of course, if you as the provider need a bit more of the know your customer, then that can be added, but it's not a necessity to have all of the data for every single service.
You keep saying there's no back end. Where does the blockchain run then?
The blockchain, it's not something centralized. It's being run on many different computers.
So there's lots of backends, not.
It's more, there are lots of nodes.
But
So
who runs them? Who pays the electricity bill? Who pays the hosting? Where does this doesn't sit in some magical plasma thing? This is a Dell server in a rack somewhere, yeah?
everybody could decide, you could decide to run a node yourself to add to the blockchain.
But then isn't there a problem of trust? So if you're taking telecoms operator and saying, oh, anybody can run a node in your blockchain, don't you have the 50% problem that anybody could effectively take over it and pollute? So do you not need a private blockchain, at which point you basically have a back end that's just shared amongst the companies?
I really love this question because this is really important. The blockchain is not something that one person can take control over. There is something called the consensus. So everything that you add to the blockchain, any data, any commitment that you make, there needs to be consensus from a certain amount of all of these computers, of all of these nodes, that they agree on, yes, this is correct. And only if there is this consensus, data can be added.
But that's consensus among members of the blockchain. And you just said anybody could run a server.
It's more the math part. So if the math part is correct, it's you don't have the, how do I place this? You do not have the authority to make a decision just by yourself. And
But if I have enough resources, I can become big enough.
Do you think you can hack half of the world's computers?
Well, it's not. It's half of the computers on the blockchain, so it depends how big your chain is, doesn't it?
The Ethereum blockchain.
You're using a public blockchain, but yeah.
they're part of it. The Oasis blockchain, it's more of a private blockchain. So this is where you can store secrets. So you can decide what is public and what is private, the data that you add. But running the nodes, it's more you're contributing to it, but you do not get, I'm the owner and I can make decisions by myself. That is not something, that is the core principle of the blockchain, to avoid that.
Interesting conversations with telco, regulatory, and security people, I think.
Yeah.
Good luck.
Right. This is sort of related, I think, to the previous question. So how important is the choice of which blockchain you use? So for example, if I'm thinking of number portability, I assume like all the, telecom companies need to be on the same blockchain in order to port that number. If someone isn't on there, then you can't do that.
Yeah, so I think we chose the Ethereum blockchain because it's a very well-established one by now, and we get a lot of different benefits. So not every blockchain has the same capabilities, or it does not allow you the same things. Like I said, there's also the Oasis Sapphire that is more for secrets. So it depends on what your use case is, but we chose this because it is very well established, and you also need to consider the transaction costs and how much do you need to pay for what. So there are a lot of factors that contribute to that decision. I hope that answered the question a bit.
Thanks.
Right. Final question before lunch.
Thank you. I'll comment on the blockchain, previous one, that there are portability run on blockchain on private ones, which are fully owned by regulators, of course. So that's private setup, which then you have a full source of truth. So it's there. Question on this demo. Do you foresee synchronization from blockchain back to internal systems or no? Because there are operations and status of purchases, billing all run internally in operator stack. Now in your demo, you run it without backend, as you say. So then there should be some kind of sync, some kind of reporting back. So this for me looks like either a light version or temporary or setup which is operational on a disaster situation, because there is a need to synchronize back with the billing system and the provision activation all backend stack.
Is there a need for that? That's a question. So with the proof of purchase, it's like I said, like the wristband. So you can prove that you paid, but it doesn't matter how or where you paid. So there is no synchronization needed necessarily, because all that you need to bring as the user is the proof.
Yes, but okay, then you go and you buy the same service, something else which contradicts with what you bought in this system. How operator know about it?
That's the cool part about this, because it's the blockchain. We can use one system, basically one general construct for all of these different operators. So there is no necessarily there's no custom integration needed, because each provider can have their own proof. They can add what they want to that proof, but in the client application that we saw, all that matters is that this proof is going to be valid. Does this answer the question, or would you like to come talk to us after? Maybe.
Okay, I'll ask. Do you have you verified it with whole product catalog structure that usually exists in telecom operator, and how products, resources, all are cross-dependent?
Could you repeat that?
Okay. Have you bounced this idea with operators and how their product catalog is structured, like numbers, packages, voice, minutes, etc., etc., etc.?
If I understand correctly, your question is if all of the services that a provider brings, if they can be.
No.
No?
Did you discuss this idea with real operators who run big product catalog? Or it's independent of, did you discuss this with real mobile operators and how their product catalog is structured?
I see. So yeah, we have, for example, a eSIM company already in conversation with us, and we asked them, of course, what would they like to offer. But the point is that you can bring one provider, for example, might only want to offer numbers, but doesn't want to necessarily offer the service. So another provider could come and use these numbers and add their services on top. That's this. I think we should after.
Catch up afterwards.
Yes.
Right. Well, lots of questions. Blockchain is one of those things that like I half know about, but at the same time I don't know about. So thank you very much, Ariana.
Thank you.
We're stopping for lunch. Lunch is not with us. Lunch is go find something that you like. I'm just checking my schedule for when everyone needs to be back, because I don't know our schedule off the top of my head. 2:15. So it's 12:50 now. Yes. 2:15. I've been told that Germans don't understand 8:30. They think it means different. So 2:15 is when you need to be back here for our voice AI section for the rest of the day. Thank you very much. Hello. Take your seats. Ah. Oh. I think the projector has turned off. Do I just press the power button? I've pressed it. We'll see what it does. There we go. Did everyone have a nice lunch? What did you go and have? Pardon? Oh, kebab. Kebab? Kebab? Kebabs all around? Hmm? Ramen. Oh, posh. Oh, there we go. Do you want to? I don't know what I'm doing. It's PowerPoint. Where is it? Slideshow. Play from start. There we go. Cool. Okay. Well, welcome to the afternoon of day 2. I've got Dave Horton here from the Jambons. I flip between both. Yeah, I still flip between two. He's from the Jambones/Jambons project. He will correct me in a minute. I've been using. You're also the author of Dractio. Dractio is a core part of Jambons, and I've been using Dractio for years now. I love it. And then Jambons kind of came along and made my life a lot easier in a very repeatable way. So I love Jambons. But I will let Dave tell you all about Jambons and what's happening with AI. Thanks, Dave.
Okay, thank you. I'm Dave Horton. I'm super excited to be here at CommCon, back at CommCon, I should say. I was reflecting the other day, as one does when one gets older like me, looking back on my career, and I realized that CommCon's had really a big impact on my career, really on my life, I guess, in a certain kind of ways. I remember when I came to the first CommCon, or I don't know if it was the first, it was my first. I think it was the first. It was the first. And I was as a Yank, I was completely unprepared for it. Dan had us under lock and key at this English estate. I think, and my first, impression was this guy's a control freak. I mean, I think he might have locked us in our bedrooms at night to really be in control. But he'd created this amazing experience. I found myself, shooting crossbows and herding goats, things I hadn't prepared for at all. It was great fun. But what's been even more important to me about CommCon is the community. I had been working really alone in open source for many years, or not many years, but several years at that time. And, I found this community that Dan had curated that was incredibly supportive, and met a lot of youth from that, colleagues like Sam through that. So really grateful for all that Dan has done to put CommCon together. I think the best tribute I could say is that he's created a community that reflects the values that we all see in Dan, which is kind, funny, and smart. And I'm just really thankful to be back here. So yeah, I'm giving a short talk, and then I'll give way to Rob, who will be much more interesting as a actual practitioner of the art on Jambones. And I wanted to talk about building voice pipelines in Jambones, and it will serve as a little update on what Jambones is doing. So as context, let me give you very brief sort of history of Jambones. And back in 2014, I had sort of my previous startup that I'd created. It kind of crashed and burned, and I was sort of walked away from the wreckage, scarred and burned, and trying to figure out what to do next. So I went on a sabbatical to Wales with my youngest daughter, and we lived there, and I was doing consulting, and I was building some web apps, and I got very interested in Node.js and how people were taking these patterns to web, and I thought it would be neat to bring that to SIP, so I created a Dractio SIP server and started doing consulting around that. In 2017, a bunch of my consulting work involved clients that were coming off of CPaaS systems like Twilio and Plivo for various reasons, and I thought, oh, we could sort of level this up one and build an open source CPaaS, and that was how Jambones really started. In 2020 or so, LLMs came on the scene, and we sort of found ourselves, without really ever thoughtfully pivoting or doing anything thoughtful, kind of in between these two worlds of telephony and AI. And a lot of people in the AI space didn't know much about telephony, and in many cases didn't want to know about telephony. That was great for us. We could kind of start connecting these two things, and we got used as a voice AI gateway first, and then more recently, probably described as a voice AI orchestration platform. In this past year, we modified our approach. We had been open source to now, and we introduced a commercial software license. So why did we do that? Generally speaking, nobody wants to see that or is enjoying it. Why did we do that? Well, it was my feeling that all through this progression, I wanted the software to be the best it could be. In many cases, I found myself in the way. In many cases, I had to say, get out of the way of the software. I wanted it to be the best incarnation of what it could be. It was possible, and many of us have done it, to build an open source, vibrant open source project in the telephony space, but I think that's partially because the telephony space is fairly mature at this point. We have new protocols every now and then, but we know what we're dealing with. It's pretty mature. AI, on the other hand, it's so dynamic, and there's so much going on that you find yourself needing to invest in multiple things at once. A certain amount of rabbit holes you're going to go down and waste resources on. It didn't seem like it would be possible to build the product that I wanted to build. So we now have this dual sort of licensing model. So we have the open source, which we still maintain, and gets used a lot, particularly voice AI gateway kind of stuff, and then the commercial version we release under 10.2. Brief slide, who builds on Jambones? So we've been very lucky. Jambones gets OEM'd and baked into people's platforms a lot in the conversational AI space. I say it's lucky because it means we get the benefit of a lot of road testing and load testing, and it gets deployed at customers like Fortune 50 companies with really high standards, which is great for Jambones. What's new in this latest release? Sorry, I've got to turn and look at it a little myself. So basically what I'm talking about today is building voice agents or cascaded voice pipelines. We also support speech-to-speech pipelines. We added support for turn-taking models. We always had a bring your own everything philosophy. Carrier speech extends to LLMs. And all the other stuff that you basically would expect in a platform or a tool or orchestration hardware. I shouldn't say all the things. I'm sure that there are many more things people would expect, but there's a basic set, and this would be, I think, the basic set. Additionally, we added some new SDKs. We always were kind of Node.js first, so we have a new Node.js SDK based on a proper JSON schema. We added a Python SDK and a WebRTC SDK, where we've been a bit weaker in the past. And the SDKs come along with an MCP server that I'll show briefly to help agents build applications. I was going to just show a quick video using the MCP server. I made it as a video. Oh, hold on a sec. I guess that didn't switch. Maybe I've got to, well, okay, maybe this will be big enough if I show it here. Okay, yeah, so basically you can add the MCP server. There's instructions on how to do that on our GitHub. I use Claude, so I've just added it for Claude. And so now it knows about our JSON schema. It knows the SDK. It has a bunch of examples to work with. And I've said I want to build a voice agent. I want to use DeepGram for STT. I want to use Rhyme Labs, which I misspelled, for TTS. For the LLM, I want to use Base 10 as the provider with the NVIDIA Nematron Super as the model. And it just will run through and do a good job of building the app for me. We'll take a look at the code in a second, which is going to be fairly easy for you to understand, I think. I'm not sure if that's easy to see, so let me just see what happens if I switch to my editor here, we can maybe see things better. It's really not a lot of lines of code, and it's pretty straightforward. As you can see, I mean, it's a very similar kind of, choose your plugins, organize them. In this case, I've chosen the SDT, the TTS, the LLM. I've got turn detection, crisp, early generation true. That's just, feature that a lot of voice agents have, speculatively prompting the LLM. So we can kind of get the results faster to TTS if they don't change between a partial transcript and a final transcript. We've enabled barge in, and then we get events. So we get sort of turn-by-turn stream of events. So we haven't broken any new ground here. You can see this is just sort of the common way people put together voice pipelines. They are like a pipeline. We didn't feel it was an area where there was any need to break new ground. I think for the most part, these voice agents will succeed or fail based on the stuff you put around all of this. In our case, what we want to put around it is scalability and resiliency that we've been known for in the SIP world, and some pretty deep observability into how it's performing in terms of latency, because these obviously are not set and forget kind of programs. You're tinkering with them all the time and trying to improve them. So let me sort of just log in and give an example. So I won't torture you with this entire call, but this is just an example test call that I made with that app using the base 10, the LLM, the deepgram, and so forth. I'll listen to a little bit, then I just want to show some of the latency statistics.
Thank you today. Well, I'm thinking about buying a new car, and I wanted to talk to you. That sounds exciting. Buying a car is a big decision, and I'm happy to help you think it through. I've got a Honda CRV 2014 right now, so it's a little old in the tooth. I'm thinking about an electric vehicle.
I see. Your 2014 Honda CRV has served you well, but you're ready for something new, especially an electric vehicle. That's a smart move these days, with more options and better charging networks.
I've got a budget of about $40,000.
$40,000 is a solid budget for a new or slightly used EV these days.
Pause that. There, you get the basic impression. Kind of a voice AI application. But what we have tried to do here is give you sort of turn-by-turn details. And if we click on a turn, we can see the transcript of what the user said. I can see the confidence levels that came back from the transcription engine, and the word-by-word level confidence, the minimum confidence. The text-to-speech, obviously, that we sent. When we barge in and interrupt the text-to-speech, if the speech vendor supports it, we use the word-level timestamps and try to get an accurate transcript of what was actually said. And then the latency. So we have the SDT latency, which here was a little over 1 second. There was no end-of-turn latency on the end-of-turn detection. The LLM was pretty fast, 273 milliseconds. The TTS, 376 milliseconds. So basically, we can see this kind of for every turn. We can see if there was issues with any particular part of it. They're kind of highlighted up here, so I can see them at a glance. When we barged into a turn, we can show that, and so forth. So that's kind of the session observability feature that we have bundled with voice agents. This is something you sort of opt into when you have an account. If you down here for observability and testing, you can choose full observability or just the recording, or no observability at all if you don't want any of these artifacts saved. That is that. The one other thing that we added, which I think will be helpful for people in this release, was just the ability to update the system through the portal. Here we'll check for updates, although. Oh, sorry. Yeah, I was running on a license. This just expired. So that didn't work. But it will check for updates, and then you can click a button to update. Updating our system's always been sort of a challenging thing for customers, so we wanted to fix that as well. One last thing that we did add, and then I think I'm done. We kind of actually saw this. Yeah, we kind of saw that. view that. We have the ability, you know, if tool calls take a long time, we can play filler noise or filler information or filler chat, I guess, if you will, and configure that as well. We generate that through the LLM as well. Yeah, that's basically what I wanted to show you guys. So if you have any questions, happy to answer them.
Has anyone got any questions for Dave? Yes. I think it's important to say that you're still improving the open source version of Jambons.
Yeah.
You're just adding the ability to make money with the commercial version.
Yeah, that's correct.
Sorry, not technical, maybe business question. How do you see where voice AI agent market is going 2-3 years time frame? Like, will they be everywhere, or what's the future?
I'm spectacularly bad at projecting the future. I mean, so I will give an unsatisfactory answer to the question, I would say, at the outset. I mean, I think there's huge opportunity for growth just because voice interactions historically have been so terrible with automated systems. And now everybody's getting really comfortable with this idea of inorganic intelligence that's part of my life that I can reach out to and grab. That's not really yet manifested in the voice world. I think a lot of us still, you know, we hit a voice prompt, even if it's voice AI, we're like, oh God, here we go again. I think there's huge growth just from, you know, the improvements that we'll see in voice technology. I guess I don't have anything particularly sparkling to say beyond that.
James.
Yeah, Dave, thanks for that. Can you just spend 30 seconds just going over some of the really good stuff that's in 10.2? I'm being lazy. I haven't looked yet. So just get me excited. Get me going.
Okay. Well, we did spend a lot of time on voice agents, and we really want to help people build voice agents on Jambones. Like, we have a lot of traffic going through Jambones to a platform like LiveKit. And our idea is, well, let's make that so they can build things on LiveKit. So that's clearly a big initiative for us. And then capturing the latencies at a very detailed level so people can do that. Upgrading the software is actually a big thing for a lot of people. It's just, you know, in the open source world, we sort of have always tried to improve that. We started with, you know, here's a bunch of GitHub repos. It's like spilling a box of parts on the floor. You go build it. That was fine. We improved that. But then people, you know, the updates weren't so great. So we had to do that. We added support for obviously a bunch of LLMs and new STT vendors. I think the MCP server to make it easier for people to build applications. At one point, we spent a little time building a low-code editor, and then we realized that's kind of pointless. Those are designed for people. People aren't really writing apps anymore. Claude doesn't need a low-code drag-and-drop editor. So, you know, we switched to the MCP server. Yeah, I think those are the main things that we've added in this release.
Anyone else? No? Well, I want to say a big thank you to Dave anyway, because I use Jambones. I'm going to say Jambones forevermore. We build a lot of stuff with Jambones, and I can see all the pluses that 10 give you. Saves me a ton of time, and it will save us hours and hours and hours. So it's great to see Jambones A, improve, but then B, you've committed to making the open source, keeping the open source stuff open and updated. Not to the same extent as commercial, because that's the point, right?
Yeah.
But you've been very open with why you've done commercial. There's a blog post on the Jambones blog that explains all of it. No one can be upset about someone wanting to make money to be able to then carry on developing open source software, right? Mm-hmm. So thank you very much, Dave, for that.
Thank you.
It was the first CommCon. Dave keynoted for me because I loved Directio. and I wanted more people to know about Jactio. I should know who's up next. Is it you? I think it's you. Would you like a headset mic, or would you like a... I'll just take that. You'll take that. Okay.
Fantastic.
Right,
Thank you, Dan.
What can I say about Rob while he's getting started? Rob's this person that continually drives forward innovation, which I find pretty cool. So I'll let Rob introduce himself properly. Thank you very much, Rob. Everyone give Rob a round of applause.
Fantastic, Dan. Thank you. How can I introduce myself? It was really, really interesting listening to Dave talk about Jambones and his first visit to CommCon, because I'm pretty sure that was mine too. And listening to Dave talk about Jactio got me going down a path with some alternative approaches to voice AI. And that kind of came to fruition in 2023 with the sort of the first iteration of playing with large language models. So I stood on a stage in 2023 at CommCon with, you know, this lashed together demo of a large language model on the telephone, and asked the question, should we put LLMs on the phone, hallucinating, waste of time, useful tool, or danger to humanity? It kind of seems like humanity has now decided that it wants large language models on the phone. So I'm going to talk a bit about all the things that have happened since then and where we're going with some of them now. So I love the way that Dave was showing all the observability features in Jambones, because all the stuff we were doing back 3 years ago was about doing cool demos that showed that, you know, kind of 10% happy path. Or rather, that's where all the, you know, it takes like 10% of the work to make a demo that works really well on this stage. But delivering an actual service people want on every medium, every network at every available moment is like the other 90% of the work. And all the stuff Dave was talking about, latency, turn-taking, interruptions. I remember standing there and doing that demo. I'm not sure whether Dave was in my talk at that CommCon, but I think there was a thing in Paris, one of Alan Quayle's things a couple of months later, where I did the demo of LLMs on Jambones, and Dave stood center stage in the audience about where that camera is there, stroking his chin, and then asked me a bunch of questions about latency and turn-taking and things. And I could tell at that point he wasn't entirely sold on this idea of putting large language models on the telephone. But I kind of persisted anyway, and he's obviously separately persisted in Jambones. And really, it's about sorting all of those problems out. And speech-to-speech for me has helped here. So I went off down the angle of speech-to-speech solves a lot of the latency problems. And because those models are building in their own interruption models, it kind of solves you having to go and fix that. In the meantime, I think a lot of work was going on with pipelines. And I kind of confidently predicted a couple of years ago that pipelines would be dead by now. They clearly aren't. And they're clearly still very important for some really good reasons, actually, that I think I now understand. So coming back to the pipeline world, I'm actually finding it really quite good, if not quite the same latency that we can get in speech-to-speech models. It's about every channel. It's about WebRTC, as well as SIP on the phone, but making sure when you're delivering that for a brand, you're delivering all of them in the same way with the same models. It's about every carrier. It's not just about gluing, you know, Twilio on the side and saying, right, now we're doing telephony. And it's also about the things you actually do on a call. Again, you know, cool demo, landing a call on an IVR that, well, not IVR, landing it on an LLM that answers 90% of the user's questions. But you know what? They called the organization up probably because they think that the AI on the web couldn't answer their questions, and they actually want to speak to a human. So if you can't deliver a joined up conversation with that human, then you might as well not be there. So actually delivering things that are embedded in the customer's telephone network and can do things like consultative transfers, find people, find who they should be talking to. I guess smart IVRs, right down to, you know, the stupid stuff like DTMF is still a lot better for capturing numbers than listening to someone say one and all of that kind of thing. And also all the things around reliability to know when a channel or a model regresses. And one of the big reasons for that is that there is this, you know, kind of complete conflict or two worlds clashing really in AI and voice. And I'm not talking about the carriers in this room, because the folks who are at CommCon really understand stuff. But if you look at folks who might be running, you know, a kind of a 10, 20-year-old SIP platform and want to bring voice AI agents into it, there's a whole bunch of stuff there about the kind of quirky way that some people do SIP and the things that you need to interface in, and all that stuff just takes forever to sort out. Whereas LLMs move in weeks. You know, the providers are shipping a new frontier. Every time I open any newsletter, there's a new model that I need to worry about, integrate, and people are going to call me and saying, what do we do with this? And kind of gluing those two worlds together is a big part of what people operating at the kind of front of this are doing. I'm not going to expand on that quote, but it's one of the things that I've had for a little while, that effectively telling people that they need to fix their implementation or your interpretation of an RFC is better than theirs is a pretty good way to lose customers. There's also a bunch of functionality stuff. I'm not going to go into this in too much detail because I think I've got too much material in here, but you need to be able to do things like bridged and refer transfers, because there are places where you've got to do bridge. There are some carriers that won't just take a refer back from you. In fact, most, if you're on a trunk, and you've therefore got to be able to do things like refer-based transfers to finalize a consultative transfer. So over those intervening years, we've kind of come up with this kind of infrastructure and model, and we now integrate with all the major kind of open source providers, so Jambones. Ultravox is a bit of an interesting one because we do raw WebRTC speech-to-speech with them, and then LiveKit, and latterly PipeCat. We've just integrated PipeCat to deliver WebRTC, SPC-based trunk calls to get calls in from SIP providers, and also registrations through a back-to-back UA. And I'm going to talk about a bit of detail on that sort of stuff. So we end up with a model like this, where really we're quite a thin shim. We're an orchestration layer that brings all this stuff together. And then we've got a Camma Elio SPC sitting for trunks to come into, and then free switch back-to-back UA containers pulling in registrations on customers' PABXs, feeding them all to the relevant runtime, and we do that thing where we feed our runtime a single piece of JSON that says, you know, go and run a GPT real time on LiveKit and connect it to this phone number. Go and run a Ultravox real time on PipeCat, or a DeepGram Gemini 2.5 11 Labs pipeline and run it on PipeCat. And we do the piece that pulls all that stuff together and makes it just work. In terms of how B2B UA works, I have this kind of model that I switched to from Asterisk a few years ago. I don't really know why. I do know why. And that's basically to pull up FreeSwitch with a config server that's running in Node and pulls the configs in and feeds them to FreeSwitch using mod XML curl. The reason I like that is that it gives you a very kind of staticky thing going on in FreeSwitch, so you're not doing loads of stuff actually on the dial plan at dial plan time. Whenever I've had problems with real-time systems like this, where you're doing real-time queries back on databases, that's where things get gummed up. Your database queries slow down, and all of a sudden, like, the whole thing is deadlocked or live locked. So building as much config statically as you possibly can, and then having an ESL Polo reporting back and filling the database, that basically allows us to build something where we've got multiple FreeSwitch containers coordinating. They're building the config from a database of the registrations that we want them to have in a multi-tenant way. And then we pull the media directly, if we possibly can, from the customer's PBX to either LiveKit or PipeCat. There's a similar thing in Jambones where Jambones does the registrations directly, but this is how we basically ended up doing it for LiveKit and PipeCat. Similar thing for trunks in Camelio. I'm not going to bore everyone with this. Everyone knows what Camelio does, or most people in the audience know what Camelio does, what its strengths are. And again, that's about pulling in multiple trunks, doing all of the cleaning up stuff to make them work, and then feeding them into whatever we're using for the SIP backend. LiveKit SIP, if you're using the LiveKit hosted version, is quite picky, and SIP trunks have got all sorts of quirks, so you end up having to do a bunch of cleaning up between those two things to get them talking to each other and get the media flowing. Life's a bit easier with what we've done with Pipecat, and I'll talk about that a little later. How this kind of plays out on LiveKit. LiveKit have an interesting architecture where effectively their SIP connector, certainly if you're using the whole hosted stack, you bring the call into a room, so call comes through their SIP stack, lands in a room. You provide, or you use their hosting service to provide a bunch of workers. When a call lands, they then connect that inbound call, which is sitting in a room, with a worker that you've had sitting there standing by to do stuff. And then within that, you do everything. These workers end up absolutely huge. I mean, my containers for a worker now are getting on for a gig. And they have a really nice model for resiliency, effectively, because each worker starts in a new node process or starts in a new Python process. So, you can leak memory, you can just throw everything everywhere, and in 120 seconds, your process isn't going to be there. So you don't kind of have any worries about that. The downside is these things are hugely expensive. You don't get many workers into, a kind of an 8 gig 4 CPU virtual host, but it certainly works well. For all sorts of reasons, we wanted to add Pipecat to the mix. So we went off to basically add Pipecat. A few different choices there in terms of architecture that we could use for that, but we decided on this model where we would use Pipecat to actually do the agent orchestration there, and then we would build SIP interface onto that. So the obvious one is sort of dailies hosted SIP interface, which is fine. It doesn't allow us, we don't get enough control over the SIP stack to do all the stuff that we need with refers and everything else, and deal with multiple implementations. So I reached for my Swiss Army knife, which is FreeSwitch with a config builder and ESL polar, and I figured let's just reuse that. That'll give us a way of getting SIP in there. And just as I'm starting to build that and I'm starting to build containers, I think it's 2026. Is this actually the best way to do this? Picked up SipGo and Pion for media handling, and thought I can make this much, much smaller to solve the limited problem of how do I get a media stream onto effectively a Pipecat WebSocket. And got that up and running. It's looking really nice. It ends up being like a 5 meg distroless container to do that, and it does just enough to get a call in. Compare that to my FreeSwitch pile of stuff, which comes in at about a gig. And has a whole load of stuff that I don't need in there, as well as some stuff that might prove useful. But that was kind of interesting, and that's what I was going to stand here on stage and talk about. Actually, we'll talk about that, and then proving that LinkedIn isn't entirely useless. About 2 weeks ago, I said something to some guy who was building Asterisk plugins for stuff, and Dan said, "Rob, you need to look at Voice Blender." So I, follow every instruction I ever get on LinkedIn, and did go away and look at Voice Blender. So that came into the mix as well, which proved useful because yesterday in the hackathon, I pulled that in. So my intention was to add all of these runtimes and then just play them off against each other and figure out which one gave me the best latency, how many I could deploy onto a 3-node Kubernetes cluster, and all of that stuff. So that's kind of where we are. So Voice Blender is in the mix now, and I may kill this SIP bridge thing because, if that project gains traction, then what's the point doing something similar? But seeing as I'd already made the slide, this is what goes on inside SIPBridge. We've got effectively our SBC bringing calls in. We bring them in, everything is on TLS. So it means that I can bring an ordinary port 5060 UDP put that onto TLS in the SBC so that my container is only dealing with TCP TLS connection. Don't care if the media isn't encrypted. That's the choice of the trunk that's throwing the data at me. But it does mean that I can kind of make this network a lot better. Bring the call into SIPGO for the handling. RT-pre gets terminated on Pion. Minimal codecs, exactly what I need to make telephony work, and then turn that into a WebSocket I can hand to my Pipecat worker. As I say, sort of Voice Blender does that and a little bit more, so maybe we'll end up using that. But this works quite nicely for me now. I mean, it works quite nicely, and it's really, really liberating when you find a bug in something and you can just fix it because you own the Go endpoint. We didn't have that with LiveKit. You don't have that when you're doing stuff in FreeSwitch. So, you know, as an example, there's a certain very well-known trunking vendor that sends you unencrypted traffic on a trunk that you've not enabled encryption on. If you, in your 200 OK, send them an encryption offer back, they go, "Oh, 486, not acceptable here. You didn't want encryption, so I'm just, oh, sorry, I don't want to do encryption, so I'm just shutting the whole call down. I'm not going to send you an offer without the encryption. I'm just not going to take the call." I can understand why they would do that, but it just makes it a pain. I think about a minute, you've got a fix in there that says, okay, if you get, I can't remember whether it's 486 or 488, if you get a not acceptable here in response to some of the crypto line in, just try again and take the crypto line out and see if they accept it, and of course they do. That might have taken me a couple of days to start delving inside stacks or to rewrite FreeSwitch style plans, that kind of thing. So it is quite useful to have that, to have something inside a modern, tiny, agile container. I'm becoming quite an enthusiast on that. Front end runs as a daemon set. Well, the whole thing runs as a daemon set actually, so it means I can lob it into Kubernetes cluster. I can put one, effectively daemon set means that it gets distributed across the nodes on one entire host-based networking set of pods on each node. I can auto scale them, and I can have my front end just do really simple TLS 5061 load balancing. You need the back pressure, so you need to be able to shut the pod down if you know you've got a problem, because you don't want traffic arriving on it, but it means you can do really quite simple load balancing, much easier than kind of having stuff arrive in a room and then dispatch off. I don't know which one's going to work when you get to the thousands of call point, but I like this. It's very web orientated, or very web-like in terms of the way that it allows to do load balancing. Another real problem in real world environments is testing. It works really well when you put the first trunk on there, you test it and it all works, and you've done a few tweaks in Kama-Elio to make it work, and the second one kind of works, and then you wake up one morning and you've got 15 different SIP trunks coming into your platform, and each of them's got their own quirks, and you need to do a software release that touches your SBC and touches your backend and touches LiveKit and touches Pipecat, and you need to make sure that every feature of every trunk is still working. So we developed a bit of software called Test Agent that we use. We primarily use it for regression testing, and what it basically does is tests every permutation of every feature across one of every trunk in every position, and just as a cycle test like that. And because every Rob presentation is really just a dangerous demo with some slides around it, I was going to use a video, but the sampling is utterly rubbish on the video. I didn't size it right for this projector, so let's do a live run of that. Here we go. Yeah, so all that I'm doing here is just doing a single run. So we have a test suite that permutes all of the permutations. Normally it runs in the background, and it's kind of neat because it allows me to do stuff like if I have a problem with a particular issue on a particular trunk, because I can run it as a script, you can actually just point an AI at the problem and say, my test script finds this problem in a dev environment, go find it, go fix it, look at the patch that it proposes, and often that gets me problems fixed without me having to spend a lot of time figuring out regressions. One of the things I love doing, though, is running it with a head on it.
Hello, this is the reception desk.
Hello, I need to speak to James about the quarterly handover, please.
Got it. The quarterly handover for James. Please hold the line while I attempt to transfer you to James.
Thank you. I'll hold.
So this is running quite a complex scenario where there's a three-way consult. So there's an agent driving the browser, which is talking to another agent in WebRTC, which is then calling another agent who's pretending to be the consultation target.
Hello, James.
You have been connected to James. The handshake is Echo 9 handshake.
Hello?
You have been connected to James. The handshake is Echo 9 handshake.
Verified James, Echo 9 handshake confirmed.
Thank you. I appreciate the confirmation. Now I will hang up the call.
Are you still there?
And that just delivers me an okay or not result, and we actually have a not okay on this, so that would have caused our agent to fail for some reason. And the brilliant thing is, I can just throw this at something and say, make this work. If that something is me because it's really complicated, that's fine, but I can look at the patch it proposes, and that gets us a solution to many of these problems. Okay, and that was going to be the video, but we won't do that. There's another issue when we put LLMs on the telephone, and that is the art of failing well. LLMs frequently fail. They fail because the agents aren't mature. The platforms are constantly running at capacity because they're not charging you enough for the stuff they're selling you. And sometimes, in fact, quite frequently, entire runtimes can go down. So that, that I've had customers putting thousands of calls a day through a particular platform, and that platform just, kind of dies in London for a few hours, or implements a firewall change that starts chucking traffic away. And an ability to do something sensible in the customer's network is one of the things that takes you from demo land into product land. And the options really, and again, we build this into our single model spec that we push out and use to orchestrate the clients, is to fail over to another model. That's fine. Okay, so Ultravox didn't work. Fail over to ChatGPT, or fail over to GPT. Sorry, or more likely, Ultravox didn't work. Actually, fail over to a pipeline model that goes nowhere near them. So that we're slicing DeepGram and Google and 11 Labs as a back end. 11 is quite interesting because one of the things about failover is that you want the same voice. So part of the personality of the agent is the same voice. So if it's got one voice one day and another voice another, then you kind of like that doesn't get accepted very well. And if all else fails, if live cut down, pipe cuts down, and every LLM in the planet isn't answering them, fail over to a customer. It might mean their reception desk is having a bad day, but that's a lot better than giving a number unobtainable. I have not got a ton of time left, so I'm not going to run into call recording, but yeah, you need it. It needs to be encrypted, and it should be timestamped and everything else. So in summary, there are really kind of about 5 things to large scale LLM agents at scale. One of them is the media paths. We dive into that because that's what we do as a community doing real-time media. Another really important one are the models and their agility. So if you're not building the ability to swap models really, really easily, then you're going to get caught because a new model comes out on Monday morning. You need to be able to deal with that. Telephony control plane interfaces and being able to drop right into the core of the network and do things like refers is really important. I'm not talking about the IMS network. That will still be there when we're all AI-controlled cockroaches. But the ability to do stuff within a telephone network rather than just sync calls is really important. Non-telephony interfaces are super important. They're the MCP interfaces and the prompt design that's allowing you to build agents that really do something useful, but that's kind of outside the scope of this. I've already shoehorned way too much stuff in, and testing, observability, recording are really important. And that is the end of the material that I was going to talk about. I'm astonished I've got through it in reasonable time, but Dan is kind of looking at me like,
time.
Fantastic questions.
I was going to say, has anyone got any questions? But Sam is here.
The stuff you said about failover was kind of interesting because I've been looking a little bit at this and with customers. The thing is, there's kind of 2 points of where it can fail. Sometimes to the model, it's down, that's fine. But actually, often it's almost this agent is failing mid-conversation. It's just lost the plot. It's doing, and you want to. But have you kind of looked at any of those kind of failures? Because you need to transfer some context. Is it almost then better to change the voice because it's almost I'm having trouble. Let me put you onto somebody else who can help and give it a different voice.
So the one thing I really love about the live kit model, sorry, I get slightly dyslexic, so you'll often hear me saying pipe kit and live cat. The thing I really love about the live kit model is that they instantiate a room, they put the SIP caller into it, and then they drop an agent into it. And if that agent fails or bombs, they just drop another agent into it, with that context, hopefully, or you can authorize for that to happen. And that's a really good way of doing this, actually. Except it doesn't work so well if you've already done a bridge transfer out, and you've done the bridge transfer, and then something bad happens to your agent, and then they drop another agent in, it then starts asking both callers who are in the bridge transfer. Okay. That's a failure mode we've come across. But yeah, the trouble is there's a huge cost around that. And I think actually, kind of diverting the call out at that point where you've recognized it failed, either to another agent where you give it the context and start again, or a human, because you've messed up, you better give them a human to talk to, right?
Any other questions? No? No? I'm going to take a minute to shout out VCons here. VCons, if you don't know what VCons are ways of storing call recordings and the associated metadata in a nice standard way. So VCon, the foundation, are actually a community sponsor, but VCons are the answer to, well, part of the answer to call recording in a good way. Thank you very much, Rob. Two things I keep forgetting about. Who left this at SIPGate yesterday? I'll give it to you in a minute. So there's number one. Number two, there's some T-shirts on the table at the back. They're from CommCon 2023. They've been stuck in my office for 3 years. I don't want to take them home. There's some T-shirts. I think there's a large left. There's some XLs left, and there's some XXLs left. So please take them. I don't want them. That's it. So now is coffee break for, I think, half an hour, which means we'll be back in, let me give you an exact time because Germans, 3:35 is when we are back. So half an hour. And we'll be back with Henning and Cesare. Thank you. Hello. Let's go back to our seats and sit down. Where is this German efficiency I keep getting told about?
I'm here.
You are?
My colleague. She is. She is. Oh, I know. Ah, fine.
You're here. Can we get started? You're here now, so we can yeah. James, come sit down.
Ich warte auf dich.
Come on. It's like herding sheep. Sheep are better than this.
Voice over IP cheaps.
Right, should we get going? Good. Okay. So continuing with our theme of AI and yeah, AI voice, etc. Henning and Dr. Mariam are going to talk to us about WhatsApp, which is near and dear to my heart because I've just spent the past year trying to figure out how to do WhatsApp calling in a nice way. I'm hoping you have the answer. So I'll pass it off on to you. Thank you very much. Everyone give them a round of applause.
Thank you. Thank you very much, Dan. Thanks for inviting us. And I think I started with the second CommCon. I was not able to join for the first, but I have been to some events already also. And it's always a great opportunity to meet you, Dan, and of course you, and present about interesting stuff. Yeah, together today with me is Mariam, and yeah, today we are presenting about the voice AI with WhatsApp. So we're running a company providing services, consulting services, development services for open source projects in the voice over IP world, mainly Camaleo and Asterisk. We do all kinds of things related to this, and our customers are all over Europe and also a bit worldwide, and yeah, doing it since some years now. Okay, let's start with the main part of the talk. Just a quick rundown of the agenda. Quick overview why it's interesting. What is interesting about WhatsApp? I think probably everybody has it in their phones. Everybody knows about it, but still, what makes it interesting from a platform voice over IP point of view. We will discuss about the challenges on the way. There are some challenges. They are mostly non-technical. Dan also, share a lot of pain in this matter. We will, describe the implementation with Camaleo Asterisk, and then also, of course, some part about the voice AI, how we did it and the challenges we had there. And then we will give an overview about the current status and finish with a dangerous demo as a tradition here in these matters. Great. Of course, this was a team effort. Mariam did a lot of work. Also, other people in the team did a lot of work here. Thanks, of course, for that. Not the people that presenting it, doing most of the work in many cases. So thanks for the team. We had a lot of delays during the implementation, unfortunately, and we will talk about that later. So what is interesting about WhatsApp? So it's a huge user base. Basically, we're talking about 2 billion users, 2 billion devices using it daily, which is massive. I mean, if you look to to big providers in Germany and Europe and US, etc. That if they're large, they have millions of users. Here we talk about billions. So it's quite interesting. For businesses, we don't talk about billions, but we have millions, hundreds of millions of businesses using it daily for communications to their customers and these kind of things. So for businesses, it's also a huge opportunity to go into it. And it turns out, yeah, they did actually a quite good job from a technical point of view for the zip part, how they integrated it. So it's actually quite easy to integrate into existing voice over IP platforms, existing voice over IP stack from a technical point of view. So how does it work in a nutshell? So you start with some onboarding process. You do WhatsApp belongs to Facebook since many years. So you start with some meta onboarding. You use a lot of meta tools. You need to do a business verification. So you need to do a KYC basically. You need to present legal documents about your business, that you are registered businesses, in which country and whatever. What is your tax status and all kind of information, your address, etc. And then you need to provision a Facebook application. And this is used for role management, API key management, and this is basically another requirement. This app needs to be then tested and deployed, available to be available for connection. And then basically you can do web-based API calls or zip calls. And yeah, they did, as I said, they did some good implementation choices. Everything is encrypted, TLS as RTP. You just send an invite without registration. Of course, you authenticate with username and password. They use Opus as a main codec, but also since some months, I think they support PCMA, PCMU to be more interoperable to the standard PSTN network. Yeah. And also another good thing, in my opinion, what they did is they implemented special rules for callbacks. So spam, of course, voice over IP spam, SPIT is a big problem in the normal PSTN world. With a WhatsApp, you cannot easily do it because you cannot call anybody unless they call you. So you need to call somebody first, a company basically, and then they are allowed for a certain number of days to call you back, which is really, from a user point of view, a good thing. Regarding the challenges, the business registration takes some time, but this needs to be spent. There's some way to get support. If you don't pay anything, you don't get humans basically talking to you, which is understandable from a scaling point of view, but they don't describe it. You just need to figure it out. After you paid somebody, after you paid the Facebook tax, the Facebook fees, you get support, which is actually quite okay, especially in the higher tiers. Unfortunately, the Facebook world is completely separated from the WhatsApp world. So the WhatsApp, it's a nightmare. This is the worst. And it turned out, during our registration of this application, we had a problem. The WhatsApp part was not working properly. And we tried many tickets, many escalations to solve it. So basically, we spent some months in the AI support hell. We had endless conversations with these support. There's no human escalation possible because always you'd only talk to AI agents. You talk over some web interface, you talk over email interface, everything is all AI. You cannot really get a human. In the end, we just decided this is not worth our time anymore. We stopped the project and waited. And it turns out after more than 1 month, magically, it was fixed. So they probably fixed something because we had done a lot of tickets. Maybe it was fixed by themselves because of some bug fixes on the end. We don't know, but I talked with Dan before and he had similar issues with custom projects. If you have experiences, of course, we're interested to hear about that. Great. So how do we implement it in the end? We have a Camalio. Of course, does the usual Camalio stuff, the call routing mainly. We have an RTP engine, does the SRTP. And then we used basically an AI voice pipeline, AI voice bot to connect. And then Mariam, especially with some colleagues, spent a lot of time there doing the voice over IP AI stuff, basically. From a Camalio Asterix point of view, it's straightforward. You need to support the authentication. There are ways in the Asterix, of course. In the Camalio, you use the USC module. The Facebook, the WhatsApp, they send you a special header, XFB, external domain. As I said, you need to use TLS. You need to offer the Opus codec, and that's basically it. There are actually also quite good integration guides now available from the Meta and WhatsApp guys, especially for Asterisk, for FreeSwitch, which can you help there. But the main challenges, as I mentioned, are not on the technical voice over IP side, but on more on this integration platform side. Great. Yeah, that's so far from the Camalio. If there are more questions, Camalio side, if there are more questions, of course, ask me later. We don't have so much time, so I will hand over to Mariam now to continue with the voice AI part.
Yes. So as you heard, our journey with WhatsApp, parallel or simultaneously, we were working on the other side, the voice AI agent pipeline. And during the time that we were actually given up for WhatsApp, okay, but we worked on the voice AI agent further. The idea was, and it still is, that we try different available open source tools and focus on the local models and integrate it. Local models, we tried for, well, all the pipeline from speech-to-text, LLM, and TTS, because for our clients, basically, privacy and digital independence is important. That being said, when you take these open source tools with the original out-of-the-box models that they use, well, the public or whatever out there, it's perfect. But as soon as you switch to some local models, you may get all the nonsense answers coming out, the replies that you think, okay, where the hell is this answer coming? Because we had all this integration, so we needed to deep dive into different components and also the integration parts to figure out, because it cannot be only that the model is hallucinating, because we had the model, well, LLM, for example, running separately and was producing some, well, okay answers. But altogether, yeah, fun. So we found out during our journey, our lessons learned, well, even the technical connections, the RTP and zip could make issues. The Docker host issues may exist. You may get into security troubles. Just as some examples of the technical issues that we managed and our engineers worked through, that it worked. But also for our proof of concept, we thought of integrating some other tools, yeah, like weather information. I mean, just as a simple tool to see how the LLM will work. Of course, that can also confuse the LLM, that no matter what you say to the LLM, it will give you or try to give you the temperature of that thing. Yeah, so that kind of things. People who work with voice AI agent probably know the tools, different tools if you use, they get also conflict. And this kind of things happen, and it needs a lot of engineering, as said, on technical parts, but also on the models themselves. In our experience, the turns were quite fine, but again, barge in makes also confusion of the models, and then you wonder, okay, is it the SDT or is it the LLM that's instead of asking question, starts hallucinating and produces again some rubbish. Yeah, for some time it was fun, but at some point you need that it works. Yeah. Yes, we used then finally the open source Docker, it is called. That yeah, that is in our experience working currently the best. All these challenges, that issues that I mentioned, well, that the first thing that comes into mind is latency as the problem with voice AI agent. But actually for us, latency was the smallest of the problems. Anyway, that being said, yes, what do you want to add something?
I just want to add, I mean, as similar as Rob said, the model quality or the model speed, basically, this matters a lot. So we had quite interesting experience, as you probably laugh now. So like 1 week it was working fine, and then the next week there came maybe an update, it was not working, and also with the tooling, the models are really have quite a different quality with regards to the tooling. It's really depends on the model. Some models support the tooling well, as Mariam mentioned, and some models are better in other qualities, maybe it's from the understanding, reasoning, whatever, but the model support is quite bad. So it's still an interesting journey on the local model side, I would say. But as Mariam said, we wanted to go on the local side because this is important, and we are seeing some demand also from our customers here.
Yes, so all that said, we somehow could bring the two streams together. WhatsApp magically worked at once, and the AI side, our voice AI agent was also ready. So we combined everything together, just plug all together. And I'm going to show you now. First, you start a bit, just prepare the lamp, and then you have WhatsApp. So I think you still hear me, right? So yeah, voice call, voice call, voice call. Yeah.
Hi there, I'm Sam, and I can help you with customer support today. What name should I have you as, and how can I help you out?
Hi, Sam. My name is Mariam. Can you give me some suggestion for fruity cocktails for a party? We have a party tonight at Lava Lab.
Cocktails sound fun. Are you calling about an order for party supplies? Or is there something else I can help you with today?
Just give me some example ideas. What can we mix? Maybe with whiskey.
Oh, whiskey cocktails are great if you're looking for something easy for a party. A whiskey sour or an old-fashioned are always crowd pleasers. They're pretty simple to mix up, but just to make sure I can help you with what you need today. Were you calling about an existing order? Maybe checking on a product?
Yes, yes. Thank you very much, Sam. Make that. Thank you. Bye-bye.
You're very welcome, Maria. Have a wonderful party.
Thank you very much.
Great. Yeah. So as we mentioned before, yeah. So it's sometimes it's not the most technical, advanced topics that we needs to be done. In the end, we are an integration company mainly, and we also need to do, of course, projects that are interesting for our customers. We are not a voice AI first company, at least not yet. But we do a lot of different projects, and this was a really interesting project in the last months, or at least more than half a year, I would say. And happy to hear that it's works now. And it was really dangerous demo style. So basically, yesterday evening, the colleague fixed the last stuff for the WhatsApp, and so just to be here.
Just 10 minutes ago, I called it, and it was greeting with different sentences and telling me different things. So it was really dangerous demo.
And this is something to be an outlook. We also will invest, of course, some the stuff there. I think tomorrow there will be a talk also from the ZipFront guys, obviously, about it as well. But testing, of course, is a really important thing, and we also want to invest, of course, more into testing these kind of things, because manual testing, as you all know, doesn't really scale and gets annoying pretty fast. Great. Okay, great. Thank you very much.
Any questions?
Any questions?
Yes.
Right. What was the model that you were saying that was a local model that you were running? So you're hosting that somewhere. If you want to say, I'd be quite interested in what model you're hosting and what hardware you're hosting it on.
No, it's of course everything runs on Olama, but I need to actually look it up because a colleague changed it yesterday evening, I think, or yesterday afternoon. So we made it in a. I mean, obviously, it's not so easy to get decent AI servers nowadays, but we made the decision to not overpower it. So we got a mid-size GPU server actually running in a data center in Germany, and everything is running locally there. And yeah, there is some latency, as you heard in the delays, but it's also not yet so much tuned. So we're actually quite satisfied with the latency from a local model on these not so expensive GPU. And the models, I think they developed quite a bit in the last weeks and months. Let me look it up and I will tell you in some minutes. I don't right now. I don't want to open the putty right now.
Everyone will be running local models within the next year or two, probably.
Yeah, let's hope. Would be great in Europe at least.
Nice, thank you very much. Just understand business problem you try to solve. So customer wants to run a voice AI on WhatsApp incoming calls. Do they run all the infrastructures themselves, or you provide as a service? Because to deploy Camaleo and everything else just to run one voice agent, maybe it's a bit of overkill.
Yes, no, it's a good question. Actually, I mean, our customers already have a voice platform, right? So they're using, I don't know, they're having Asterisk, Camaleo, Free Switch, whatever, right? And the larger ones, the more adventurous or more technical capable, like Zipgate here, many people are here, they're doing it already. In some cases, they're doing it with local models, in some cases with some remote services, which is fine, of course. But yeah, we have a lot of also smaller customers, which don't have 15, 20 engineers on staff. There's maybe 1, 2 guys. So they are more interested in a smaller solution. And this is one idea, basically, to have, yeah, like a limited set of voice AI services, yeah, like a receptionist, usual stuff, yeah, transcription services, maybe put product information, these kind of things to provide to them, but in a self-hosted way, basically, or as a kind of managed service, maybe, yeah. But it's still in the beginning, and we didn't jump so fast to this AI hype train, I would say. So we waited actually for our customers to have some interest, and now we're seeing some interest from our customers. Telco, our customers are quite conservative. So yeah, some years later, now we are here as well, talking about AI.
Any other questions? No? I've got a little footnote to all of that. WhatsApp had a keynote the other day, and like they're making AI agents, at least from a messaging point of view, kind of baked in to WhatsApp. So you can go and create an AI agent within WhatsApp, within your WhatsApp business, and it's able to go and talk to like your website and make orders and things like that. So I don't think it's going to be too long before WhatsApp start doing AI voice agents as well.
Yeah.
They might have already done it, but I haven't seen it. So thank you very much.
Thank you.
Thank you.
Cesare, would you like one of these mics or one of the other ones? This is fine? Cesare is going to talk about a project that I'll give you a little bit of background on. I saw him launch it, and when a couple of weeks, I think it was only a couple of weeks later, I was about to speak at OpenSIP Summit, and I messaged him and said, oh, I kind of really want to use the project that he's about to talk about. I don't want to take his thunder. But I was like, can it do WhatsApp calling? Right? He's like, probably not. But I said, oh, okay, I'll go and try and make a pull request like tomorrow or something. And then I woke up the next day and he'd already done it. He'd already gone and added support for WhatsApp. WhatsApp is very specific in what it wants. But it showed the power of being able to kind of go build something that's nice and small. So that one's still live. There you go. Thank you very much, Cesare. Everyone, give Cesare a round of applause.
Hello, everyone. It's nice to be here again. I think it's my third CommCon. Okay, I'm going to talk about this. Maybe let's start from the beginning. My name is Cesar Siwak. I've been in the artisan industry for 20 plus years. I've stopped counting at some point, but I worked for many companies before. I love open source, so this is what bringing me here. Okay, how did we used to build voice apps before? We saw this in all previous presentations. Yes, some of us use Asterisk. It's Asterisk has evolved a lot, so it's our probably first legacy platform that everyone used in the past. You starting with dial plan, you adding more and more APIs. Then back in days we started with AGI, then we moved to AMI, and then at some point Asterisk introduced ARI and etc. You still need to probably use a few of them to make it work in etc. Similar with FreeSwitch, still need to involve dial plans and etc. And to use the ESL to communicate with FreeSwitch asynchronously, and then you still fighting against limitations that FreeSwitch has in terms of calls bridging and unbridging and etc. And using playbacks, recording. There's always something that works differently that you imagine at the beginning, and you need to fix it. There's of course jambons, and I like jambons. If you're using jambons already, you should probably stick to it. It's mature, well tested, and maintained. And to be honest, if I liked Node.js and that stuff back in the days, I would probably choose jambons as well. But because I kind of not really into that bucket, I always avoided it. So I always use FreeSwitch and etc. And RTP engines and all the applications around. Okay, most of us, if not all, use some CPaaS providers and build their applications on top of it, which is fine for prototyping and going fast, etc. Everything is there. Numbers are there. The platforms are also well tested and well documented. So yeah, I guess it's okay to use CCaaS at some point. Although you are kind of at some point you need to decide whether you are sticking with those platforms or you moving to your own, if any. Of course, it's expensive to use those platforms. Okay. We can of course build our own which is hard. You know, everyone learned that it's not easy to implement all those features by your own and then stitch them together to have like a similar functionalities that either the open source projects provides or the CPaaS providers do. So that's why I started creating Voice Blender. It really started as a pet project. I was playing with I think LiveKit and I was doing something around SIP integration, and I said it's not. It doesn't work as I wanted as well. So I started like prototyping my own thing. Having, of course, the experience of building the CPaaS platforms in the past. So this is how it started. Many people ask me what the Voice Blender is, and the simple answer is it is what you want it to be, because it's fully programmable. You can only talk to it through APIs. Yeah, it doesn't do anything by itself. So you can build any voice application you can imagine. It's written in Golang. I've been doing Golang development since, I don't know, 2014, I think. It was worth mentioning that, of course, I'm using the Python for WebRTC stack and SIPGO for SIP. I wouldn't be brave to implement those by myself. So, but it's good to have a great libraries that we can use. Yeah, the Voice Blender, it's a single binary application. It's fully configurable through environment variables, so not messing around with config files and etc. The Docker image, it's fairly small. I think like a compressed, it's around 30 megabytes, and it just deploys in seconds. You don't need to use any Puppet, Chef, or any automation tools. You just can deploy it with, like I said, with the configurator, with the environment variables, and it's easy to run it on any cloud. Okay, what can you build with Voice Blender? Call centers. It's fairly easy to build call centers, which I will show you later. AVRs, again, old-fashioned PBXs and etc. Then you can make them much more modern. Of course, voice AI. We're talking about voice. I'm being put in a panel of voice AI, so yes, you can build voice AI agents and etc. Dialers, which is kind of similar to call centers. PBXs. Voice Blender provides everything that PBXs need to operate. And tests. So this is worth to mention because Voice Blender acts as a client and as a server in most of the flows. You can actually use it for testing your own application. Like you can test the full or complete pipelines of whatever you have. Yes, and in fact, yeah, the Voice Blender uses Voice Blender for testing. There is actually around 200 different use cases. They are being tested internally. Okay, so let's see how it works. So the voice blender has a concept of legs, which at the moment I'm mentioning only those two, which is SIP and WhatsApp. So you can imagine receiving an invite from this. I'm not sure why this is not showing, but there are some colors I'm missing. Anyway, there should be a box which is not visible. I don't know why. Well, that's strange. Because I don't. Lost it. Oh. Okay. I think I may need to continue. I'm not sure, but why? But the boxes are kind of not visible. Sorry. I'll just continue. So you have an invite coming to Voice Blender. The Voice Blender sends the leg ringing to your application. Then from the application, you send the answer. The leg becomes a call. Then you create a room, which at least it appeared. You create a room, which is similar concept to probably LiveKit Rob mentioned. Then you add the leg to the room. Means add the call to the room. You can play an MP3 file, which could be, I don't know, thank you for waiting, please hold, etc. At the same time, you can create a second room. And from that room, you create an outbound call to a WhatsApp endpoint, which becomes added. Then you get like connected event and etc. The call, the invite becomes a call, and when the call is created, you can move the SIP call from the room 1 to the room 2. So the SIP leg and WhatsApp leg will be connected to each other, and you can delete the room 1, and the call maybe the call stays connected in room 1. Of course, at any point you can add any text-to-speech, speech-to-text, or AI integration to a room or to a leg. You have a choice to have it connected directly to a leg or to a room. Okay, let's talk about the leg types. Yes, Voice Blender supports at the moment 6 different leg types. First is SIP with TLS and WhatsApp, and you can connect the pure WebSocket connection with raw PCM frames. You can have a WebRTC leg. You can have a mock, which is kind of experimental. I really wanted to play with it. I don't think there will be any like a serious use case for it, but there is an example and demo in the examples directory that you can play with. And the last thing which has been added a few days ago, it's a live kit. Basically, you can use Voice Blender as a live kit client. Okay, speaking about rooms, the main purpose of the room is it's mixing audio. You can configure the sample rate that is being used in the room, that the legs are being mixed together with. It's between 8 and 48 kilohertz. Of course, it's if you are just running on the PSTN and you have PSTN 8 kilohertz code, there's no point to mix audio at 48 kilohertz. So you can save some CPU. But for example, if you have a good mobile good connection with a mobile provider and you have Opus or AMR or any better codec, or even a WhatsApp. With WhatsApp, you can get HD audio, or you planning to use WebRTC clients only. You can definitely mix that higher sample rates, and then for example, your AI pipelines and speech to text, text to speech will sound much better. Okay. Mixers also provide some extra signaling, such as DTMF, fan out, and real-time text, which is kind of not relevant, but it's there. Rooms provide tabs that you can attach different things like audio playbacks, recordings, text to speech, speech to text, and agents. So you can tap into rooms with external things. And a room also provides some primitives to move legs around, muting, the earmuffing, bridging, and configuring the audio path that we'll talk about now. So you can bridge rooms together if you wish to for a specific use case. Use cases that could be, I can imagine there could be a few. The bridges could be unidirectional, so audio flows in from one room to another, or it could be bidirectional. So basically, there will be the same audio in both rooms, and you can always remove those bridges if you want to, or modify those if you wish to. One of the interesting features added recently was something called role-based audio routing. So for example, so basically how it works, when you create a room, you can define the audio paths. So in this example, the customer will hear agent will hear customers, and supervisor will hear customer and agent. And when you start adding your legs / calls, you add those legs with a specific role. So for example, in this case, customer will be able to freely to talk to agent. Then there will be supervisor on the call, and supervisor will hear customer, and supervisor will be able to talk, whisper to an agent, telling what to tell, or or providing some guidelines, etc. So routing configuration stays until the room is deleted, and participants can leave room and join together, and the routing always stays there. The audio paths stay configured. So this is kind of different to what CPaaS providers do, because I think you always need to configure those paths every time you join or leave the room, which could be vulnerable to some race conditions. Recording. it's also very important. You can create, you can record each leg individually if you wish to. So you get a stereo file with one channel being the leg and the other the room. You can record the whole room in like a multi-track WAV file when each participant, each leg is in a separate track. And the files could be stored in the local file system as well as S3. And of course, you have a full control of recording, so you can stop and start at any point. You can pause recording, for example, for when user provides some sensitive information, I don't know, credit card numbers, etc. You can pause recording and unpause it and resume recording afterwards. Yes. Answering machine detection, it's one of the first feature I actually did also. It uses simple but effective algorithms. It's just measuring energy and measuring the timings between like a speaking event. And surprisingly, it works quite well. We thought about like doing it using LLMs, but it's kind of doesn't make sense because it already works well. There is also beep detection feature, which helps you if you, for example, you have a dialer or dialer app and you get a call being answered by a voicemail. You can detect when to leave a message, for example. This feature is actually quite well tested. I've tried to find lots of different like greetings on the internet. I also there is some of the greetings are being generated by text to speech using different languages and different using like different countries. What do you say in different countries when you answer the call to make sure, yeah, it covers different scenarios in countries. As I said, it's very simple, but it's highly it is very good. It reaches 100% basically. Well, with the samples I have, and I think it detects human in 1.5 seconds and detects machine in less than 2 seconds. This is how I use it. I have a SIP proxies and applications connected to the voice blender. Okay. Again, some boxes are not quite visible here. So one of the things that is kind of important in our industry is to make sure that our voice applications are scalable, highly available, and well performing. So for that reason, you run multiple instances of Voice Blender probably, and Voice Blender is ready for that. And each event and response from the Voice Blender provides a unique instance ID that you can correlate with your application and with each call, so you can decide where to route traffic to which instance. Yeah, I think the main principle here is that you need to remember that if you want to join two calls together, they need to be on the same node, on the same instance of Voice Blender. Also, you need there's also you can, when you're connecting to Voice Blender, you can filter events based on app ID, and by doing that, you only receive events for specific IP ID, and the IP ID can be set when you're making or receiving call. It's just at the beginning. Okay, new features. recently added SIP registrations. So it's only initial support. You can send the SIP registrations to Voice Blender. There are CRUD endpoints to manage those registrations. You get all the events if anything happens with the registration. You can also send calls to registered contacts, and that also includes call forking if there are more than one contacts registered to a single AOR. The live kit, it's quite new, as I mentioned before. I think it's much better than live kit's SIP, the official SIP bridge. Basically, by replacing it, you gain all the rich features that Voice Blender has. There are Go and Python libraries. Those are auto-generated from the OpenAPI specs. So may not be perfect, but I hope to make them better. But all my examples use the libraries. The mock stuff, it only implements the draft 11, the very, I think, first version of mock. I just wanted to experiment with it, and I'm not sure about what will be the adoption in audio conferencing and calling context. Since WebRTC is quite good already, but I've actually noticed that the establishment time for mock, it's much quicker than for WebRTC in some cases. So when you make a call, it's just instant. With WebRTC, it's sometimes there are hiccups, a couple of 100 milliseconds when there is ice happening, and then if you need to answer a call very quickly, mock is much quicker in this case. So I'm going to show you some demos. The first demo, it's actually the same instances of Voice Blender running in Docker, and 3 different applications. First box is the dialer. It's the thing that makes outbound calls. Second one, it's SBC. It's just a back-to-back user agent, and this is what the application does. And this third Voice Blender instance just receives the call and plays an audio. Let me see if so top left corner is the SBC. This one is the PSTN emulator, let's call it. And the left, bottom left, is the dialer that makes a call. I'm going to run 20 CPS at 200 calls in total. Just bear in mind, 200 calls and 20 CPS, it would give in total 80 CPS because we have outbound leg from the dialer, two legs in the SBC and 1 leg in the PSTN, so it will be roughly 80 CPS and 800 calls. And this is my home computer with 12 physical cores. So you could probably see the CPU load, it's like nothing. Should finish quickly. I think the connection time is set to 15 seconds. Yeah, you have 200 calls connected, 0 failed. Okay. I have a second demo. If you have a laptop, you're free to join, maybe anyone. to go to the ccdemo.voiceblender.org/agent. You can use any user, and the password is nicehelp52. If you call the number, you join as a customer. If anyone can call, that's also fine. Yep. Okay. Did anyone logged in as an agent? If someone picked the call, yes, you can actually you have a way to transfer the call to a supervisor, which I'm here. This is my supervisor thingy. Can you try to transfer the call to supervisor? If anyone joined, huh? Password, it's nicehelp52. Yeah, because there's no agents. You need more agents. Any agents? Agents. Okay, let me. Sorry for showing your number. I think something happening with the audio. Yeah, something. Okay, it doesn't work. Okay. Okay. Let's see. Oh, transcript. Someone said hello. Oh, I can answer probably. Hello, hello. Yeah. So you're calling with, you're talking with supervisor now. And I can probably transfer it or put on hold. Yeah. Oh, it's you. Yeah. We know. Yeah. Yeah. So we have a transcript running on the background at the same time, so supervisor can see if you are being kind to the agent or not. Okay. No, not yet, at least. Okay. Okay, I think that's all I had. Yeah, if you're not using VoiceBlender yet, I'm really encouraging you to try it out. If you have any interesting project that you want to do anything new, or you want to replace any legacy system with something more modern, and you think there's a feature gap in the VoiceBlender, happy to chat and help. That's all.
Thank you, Cesare. Has anyone got any questions? Yes, Sam.
I might have missed this bit, but with the rooms, you talk about the audio rates. What about codecs? So if you've got two different legs using completely different codecs.
It's always transcoded to raw PCM. Everything is transcoded, yes.
To raw PCM at
Yeah.
whatever rate and then back out. So each leg can be on. What codecs do you support?
At the moment, it's PCMA, PCMU, G722, and Opus.
They're the only codecs we care about.
Probably.
AMR wideband.
Yeah.
Yes, Tim.
So you could get rid of 100 milliseconds in your WebRTC connection by using SIP and Snap and SPED, and I think they're supported in the. If you're using Pion under the hood, then they're supported. So
It does use
speed up
Pion.
your WebRTC.
Any other questions / comments? No? I've got a comment.
Mhm.
I love VoiceBlender.
Thank you very much.
It's a Go binary that does all of this stuff. Simple to, it's not even compiling, like it is compiling, but it's not, you don't have to go and compile asterisk or free switch, right?
Yes.
It's simple, and everything's API driven, everything's webhook driven. Yeah, like I said, I wanted to get WhatsApp talking to VoiceBlender and then have VoiceBlender talk to Pipecap. And for the most part, once Cesare had added WhatsApp support, it just worked, other than an issue that I wrote. But VoiceBlender was perfect.
Thanks. It implements only because WhatsApp has multiple way of signaling as well as media. It only supports SIP with DTLS SRTP, but you can also talk with some custom WebSockets with DTLS SRTP or SDS SRTP. Yes. And yes, as you said, it's very easy to make changes and just deploy or just run it locally. If you look at the Rob's Pickering slides with all those components, connecting to each other and doing something, VoiceBlender probably could replace like 3 pages. Of that.
Right. Thank you very much, Cesare.
I think Sandro.
Sandro, did you have a
no?
No?
Okay.
So it's called VoiceBlender. Will it do video?
It doesn't do video. So VoiceBlender is technically an MCU because I think it's decoded and mixed together. If we do something for that as a video, I don't know what would it be. I'm not going into this territory yet.
I'm buying videoblender.org right now. Thank you very much, Cesare.
Thank you.
I still see T-shirts on the table behind me. I don't want them there when I leave. Please take them. That's it for today. Something I didn't make clear on the schedule. The party drinks is drinks. Drinks aren't here. Drinks are back at Zipgate at 5:30 onwards. So, it's a 20-minute tram. 20-minute tram, isn't it? Or so. But there's beer and food, yes. So head back to Sipgate if you would like beer and food and to continue fun conversations. No pineapple pizza. It's not pizza tonight. Cake. So that's it for today. I don't think I've got anything else to say other than, yes, see you at Sipgate, and we'll be back here at 10 o'clock tomorrow morning for another fun-filled day. Thank you. Lightning talks. If you want to do a lightning talk tomorrow, it's 5 minutes long. You have to tell us about it before lunch tomorrow, in some form. Email me, grab me, politely. 5 minutes between, I think, 2:45 and 3:15, or 3:15 to 3:45. I can't remember. Lightning talks.